Introduction to Cloud Computing in AWS. In this particular chapter, we will be covering overview of cloud computing, AWS fundamentals and core services, setting up an AWS account, followed by an hands-on exploring the AWS Management Console and setting up a basic EC2 instance. Overview of cloud computing. Cloud computing is the on-demand delivery of computing resources over the internet such as storage, databases, servers, networking and software. It enables users to rent IT infrastructure without the need for large upfront investments. Resources can be scaled up or down based on the user's demand, making it cost effective and highly flexible. Some of the key characteristics of cloud computing includes on-demand self-service. Users can provision resources as needed without human intervention. Then we have broad network access. Cloud resources are accessible over the internet from any device. Resource pooling. Cloud providers pool resources to serve multiple customers using multi-tenant models. Scalable and elasticity. Resources can be dynamically scaled up or down based on demand. Measured service. Pay only for what you use through a utility style billing model. Now next, we're going to look at advantages of cloud computing. Cost efficiency reduces capital expenses for purchasing hardware and maintaining data centers. Your speed and agility. Provision computing resources within minutes. Global scale. Access services from anywhere in the world with low latency through a network of data centers. Performance. Cloud providers maintain the latest hardware, resulting in faster and more efficient systems. And finally, security. Advanced security features such as data encryption, DDoS protection, and access controls are often integrated. AWS fundamentals and core services. Now, AWS or Amazon Web Services is the leading cloud provider offering a wide range of service across compute, storage, databases, networking, machine learning, and more. AWS helps businesses deploy and manage applications at scale. Some of the key concepts of AWS include regions and availability zone, where AWS operates in multiple regions globally, each containing multiple availability zones or AZs. AZs are isolated locations within a region that provide redundancy in case of a data center failure. There are also edge locations. Edge locations are used to cache content closer to users for faster delivery using services like CloudFront. Then we have the AWS core services, which include compute. To start with, Amazon EC2, which is Elastic Compute Cloud. It provides scalable virtual servers, which are instances. Users can launch, configure, and manage these instances based on their needs. Then we have the AWS Lambda, which is a serverless compute service that lets users run code without provisioning or managing servers. And we have also Elastic Beanstalk, an easy to use service for deploying and scaling web applications and services. You don't have to remember the definitions for these. We're going to cover all these in detail as and when we go through this video series. Next, we have storage. The first one is the Amazon S3, which is the simple storage service. Scalable object storage for data and like files, images, and backups. Next, we have the Amazon EBS, which is the Elastic Block Store, persistent block storage for use with EC2 instances. And finally, we also have the Amazon Glacier, which is low-cost storage for data archiving and long-term backups. Next, look at some databases. We have Amazon RDS, which is Relational Database Service, which is managed relational databases. Example can be MySQL, PostgreSQL, and Oracle. Then we have Amazon DynamoDB, which is a fully managed NoSQL database service. And we also have the Amazon Redshift, a fast, scalable data warehouse solution. Next core service is networking. We have Amazon VPC, which is a virtual private cloud, which enables users to provision a logically isolated network for their AWS resources. We have the elastic load balancing, which is ELB, which distributes incoming traffic across multiple targets, EC2 instances, containers to ensure high availability. Then we have Route 53, a scalable DNS and domain name registration service. Next, let's go over setting up an AWS account. For this, you'll have to sign up for AWS, choose an AWS support plan, and enable MFA, which is multi-factor authentication. And finally, we will go over exploring the AWS free tier. So let's jump into it. Step 1 is to sign up for an AWS account. I already have an account, but still, I'm going to walk you through the steps. First, it says create an AWS account. So visit the AWS website, which is aws.amazon.com, and on the top right, you'll see a create an AWS account button. So click on that. This will take you to the sign up page. Now the sign up page will ask you for a root user email address. This is used for account recovery and for some administrative functions. Then it will also ask for AWS account name, which you can change later in your account setup. So I'm going to go ahead and give my email and my account name, and say verify email address. Now it will send me an email for validation. For me, it's 795870. Click on the verify button. Once it's done, it's your email address has been successfully verified. Now it will ask you to create a strong password. Create a strong password here. Make sure all those requirements are set, and then continue. Next, it will ask me for contact information. And once I fill out this form, I'm going to go to step 2, which is billing information. And once I provided all the information that needs, I'm going to say verify and continue to step 3. Here, it will ask me, how do you want to verify your identity? I'm going to say text message, country, and give my phone number. And I've got the verification code, which I'll enter here. So next is asking me to sign up for AWS support plan. So there's this basic, which is free, includes access to AWS documentation and community forums. We also have the developer support, which is $29 per month, which is paid support for test and development. Next, we have the business from $100 per month, which is for production environments with faster support. And also there's an enterprise level support for mission critical applications with a dedicated technical account manager, which starts from, as you can see here, $15,000 a month, and you will receive 15-minute response times and concierge style experience with an assigned technical account manager. I'm going to say I'm just going to stick to this. Say complete sign up, and it will say congratulations, thank you for signing up for your AWS, and it's saying we are activating your account, which should take a few minutes, and you can say go to AWS Management Console. So AWS offers a free tier which allows new users to explore AWS services for free for the first 12 months. Services like EC2, S3, and Lambda have free tier limits, example 750 hours per month of EC2 usage. Finally, let's look at the hands-on, where we will be exploring the AWS Management Console and setting up a basic EC2 instance. First step is to navigate to the AWS Management Console. Step 2 is launching an EC2 instance. Step 3 is configuring your instance. Step 4 is review and launch the instance. Step 5 is connecting to your EC2 instance. And finally, installing and configuring a web server. So these are the 6 steps that will follow, and make sure that you follow along. Let's get started. Let's start with our hands-on experience, where we will explore the AWS Management Console and deploy our first EC2 instance. So the step 1 was to navigate the AWS Management Console. And as soon as you log in, the thing that you see is called the AWS Management Console. This is the web-based interface where you can access and manage all your AWS services. Some of the key areas of this console include the search bar, which is here on the top, where you can quickly search for services like EC2, S3, and Lambda. So you can do EC2 and jump on there directly. The search bar will still be there. You can switch to something else. You can do S3, jump to S3, or if you want Lambda, you can go here and search for Lambda and jump to Lambda. So this is the main search bar, and I can go back to the management console by pressing this AWS again. So this is back to the main dashboard. Now it will show me recently I have visited these, and it will keep on showing them here. We also have the services menu here, which you can click and go through different services. It lists all the AWS services by category. If you see here, it has all these categories. You can also look at all your services here, which will show you all the different services under their respective category heading on the top. Now, let's start with our EC2 instance. So how do you launch an EC2 instance? Well, first, let's go to EC2 by clicking here. This is one of the ways. You get to the EC2 dashboard. Here, you can click on that launch instance button over here to start your EC2 service. When you get here, Amazon provides you this step-by-step widget which will let you create that EC2 instance. So first, what I'm going to do is I'm going to give a tag to my server. I'm going to call it my first web server. Also, you can add additional tags if you want to. Next, application and iOS images, which is AMIs, which is Amazon Machine Images. I usually use Amazon Linux or Ubuntu for trial purposes because those have free tier eligibilities. If I click on Ubuntu, I have this. In Amazon Linux, I'll say confirm changes because since I'm switching, and it has that option here. Next, instance type. Depending on how much capacity you want for them from this instance, you can select different ones. The default one is T2 Micro, which is eligible for free tier, which is free tier eligible. And then we have many more. If you want something smaller, something bigger, you can select based on what your capacity that you're looking for. Now here is the key pair login. I can select if I have one here. It says proceed with the key pair not recommended. Without a key pair, nope, not recommended. So I'm not going to do that, but I will create a key pair in the next step. Network settings. I have my network settings here, which has the VPC selected here. We have subnet, and it will automatically create if it doesn't exist. Also, we have configured the storage. It gives me up till 30 GB if you see here, but it's selected 8. I don't care about it because I'm building a simple web server, Apache web server, so I don't need anything. There's advanced details if you want to look at other things like domain, join directory, IAM, instance profile, which we'll learn as and when we do more projects in the future chapters. But for now, I'm going to keep the default. Also, number of instances, I'll keep 1. I don't want multiple instances running, and it gives me all the options here, and I'm going to say launch instance. So all I've added was the name to it and selected the particular AMI for this. So now it's asking me to create a key pair. So I'm going to create a key pair. I'm going to call it my web server key, and I'll keep RSA, I'll keep PEM, and I'm going to say launch instance. And this will start my instance, and also it will download my key. So here I'm going to move it to my desktop folder. So that's good. Next thing, I'm going to go back to my EC2 and look at my instances that are running. I have one instance here. I can select it and I can look at the instance, and in the details I can see this is the IP address. If I open this right now, it will not work because I have not enabled anything. Also, I have the host names, the private IP DNS, all the information is right here about it. You can look at different status and alarms, monitoring. It also created a security group which allows me to look at do SSH to it on port number 22, but I also want it to so I can open it from the browser. So what I'm going to do here is I am going to, inside my security group, I am going to edit the inbound rules. I'm going to add another rule, and this time, since I want to access it from HTTP, I'm going to say HTTP port number 80, and I'll say enable everything, all the traffic. save rules, and that is saved for that security group. Go back to my EC2, again go back to my first web server, have that here. Now if I want to connect to it and install my Apache server, what I'm going to do is, let's see, it's not loaded. So what I'm going to do here is I am going to select this and press the connect button. This will give me information on how to connect using SSH client. There's also directly EC2 instance connect, where you can directly press the button connect and it will open a terminal right here, but I want to do it using a terminal. I'll go to my desktop because that's where my key is. Let me make sure it's there. Yes, it's there, the my web server key, and I'm going to say SSH minus I. The steps are right here. SSH minus I, say my web server key. They've added a quotes here because sometimes you put spaces in there, that's why. And the user is EC2 dash user. Now where do I get this from? Just you get it from here, or you can also look at the users here that I have. So that is automatically created for you. At the rate, I'm going to just copy this because I can't type that much. And it says that it will the authenticity of host can't be established. So do you want to proceed? I'm going to say yes. And it gave me a error here. The permission 044 are too open. So again, one more thing that you'll see here is it's saying chmod do this, which I forgot. So I'm going to go here, I'm going to give that permissions, and then try to run that SSH command again. And now I am into my EC2 instance, so I've connected to that. So always follow the commands that they give you, just to make sure that everything works fine. So I'm in there now. If you're not familiar with how to install an Apache server, here is it. First I'm going to go and check my yum, if it update, make sure it's up to date. That's good. Next I'm going to install httpd -y. So this will install my Apache server. And next I am going to say sudo system control and start my httpd server. It will start it, no errors, perfect. And then I'll say system, so it doesn't shut down automatically, it restarts on it automatically. So I'm going to say enable httpd. Make sure that the service is always running. Now I'm going to go back to that URL and refresh, and there you go, it works, which means the server has been started and it's running. So that's how you can create an EC2 instance, run Apache server on it, and run your website on it. So in this particular video, we have covered cloud computing and how cloud computing allows you to access computing resources on demand, offering scalability, cost efficiency, and flexibility. We also did how AWS provides a robust set of services across compute, storage, databases, and networking, making it a leader in cloud computing. We also saw how AWS provides a robust set of services across compute, storage, databases, and networking, making it a leader in cloud computing. We also went ahead and set up an AWS account, which was pretty straightforward, and the AWS free tier provides a great starting point for learning and experimentation, and that is what we used, where we created a hands-on exercise where we did a basic EC2 instance and uploaded and created our own Apache server, ran our own Apache server. This particular video lays the foundation for working with AWS services and managing cloud infrastructure. If you have any questions or got stuck somewhere, let me know in the comments and I'll get back to you as soon as possible. Thank you. Welcome back. In this particular section, we're going to look at AWS Management Console. We will cover introduction to the AWS Management Console, navigating through AWS services, using the AWS CLI, which is the Command Line Interface, and then we will look at hands-on how to use AWS CLI to launch and manage EC2 instances. So let's get started. First, introduction to AWS Management Console. The AWS Management Console is a web-based user interface that provides access to manage all AWS services and resources. It is designed to help you launch and control various AWS services, monitor account activity, and manage cloud resources visually. Some of the key features of the AWS Management Console include Unified dashboard. The console provides a single interface to manage all AWS services. You can navigate between different services, view billing information, and monitor usage. Then we have the search bar. Use the search bar to quickly find and access any AWS services like EC2, S3, Lambda. We have service shortcuts. Customize the dashboard by pinning your frequently used services for faster access. We have account and billing information. The console provides easy access to billing dashboards where you can track your AWS usage, set budgets, and view billing reports. The console also offers various tools like AWS Cloud Formation Designer, EC2 Instance Connect, and AWS Cloud Shell, all of which help with deploying and managing cloud resources without leaving the interface. Let's look at navigating through AWS services. Now, AWS provides a wide variety of services that you can interact with via the management console. Here's how to navigate and access these services. First, through service categories. The service menu is divided into categories including compute, whereas EC2, Lambda, Elastic Beanstalk. You have storage, which consists of S3, Glacier, EBS. You have database like RDS, DynamoDB, Redshift. Networking, which consists of VPC, Route 53, ELB, and security and identity, which is IAM, Cognito, and Guard Duty. We also have search for services using the search bar at the top of the console to quickly find the service you need. Type the name of the service and it will display relevant options. For example, typing EC2 will take you to the EC2 dashboard. And service dashboard. Once you select a service, you will be taken to the service's specific dashboard. The dashboard will provide information and options for managing resources within that service. Example, what we saw previously, the EC2 dashboard displays information about running instances, available AMIs, which are the Amazon machine images, elastic IPs, key pairs, security groups, and more. We have customizing the console. You can customize the console to make navigation easier. We have pinned services where you can pin frequently used services to the top bar for quick access. And we have resource groups. Create and manage your resource groups, which allow you to group related resources for easier management. Next, let's look at using the AWS CLI, which is the command line interface. The AWS CLI command line interface, which is completely opposite of AWS Management Console, just FYI, is a powerful tool that allows you to interact with the AWS services using commands in a terminal or command prompt. It is an essential tool for developers and system administrators who prefer scripting and automation over the web-based management console. Some of the key benefits of using this AWS CLI is automation. You can automate repetitive tasks such as launching EC2 instances, managing S3 buckets, or creating RDS databases. Also for scripting, create shell scripts or batch files that can perform complex AWS tasks in sequence. It's cross-platform. The AWS CLI is available for Windows, macOS, and Linux. Direct service access. Interact directly with AWS APIs, which can be faster than using the management console. Now let's look at setting up the AWS CLI. So we'll be doing some hands-on in this particular case because we'll have to first install the AWS CLI. We'll then look at how to configure the AWS CLI, and then we'll look at some basic AWS CLI commands. Setting up the AWS CLI. Now, first step, as I mentioned, was to install the AWS CLI. You can just search for AWS CLI in your favorite browser and it will take you to that AWS CLI webpage. Here you have documentation, tool, release notes, bunch of different stuff. You can go through the website if you want to, or on the right side, if you're using a Windows, you can download and run this. On Mac, you can download this. In Linux, you can download this. So I'm going to go, since I'm using a Mac, I'm going to download the Mac OS package. So once it's downloaded, you can just double click on this and follow the steps. Continue, 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 agree, select your destination, what type of installation you want, installation type, how much space it will take. And once the installation is complete, it's going to give you the summary that the installation was successful. And then I'll go ahead and close it and move to trash. I don't need the installer anymore. Now once this is done, you need to configure the AWS CLI, which is the second step, which is configuring the AWS CLI, and to use your account credentials. So I'm going to open terminal, and here I am going to say AWS configure. This will prompt you to enter some of your AWS credentials. First, it will ask you for your AWS access key ID. To get this AWS access key ID, you need to go to your AWS Management Console. On the top in your account, click on Security Credentials. Inside this, there will be a section for creating access keys, and here you can say create an access key. It's not recommended for root users for access key, but I'm just using this account for now. And it creates an access key and secret access key here. So I'm going to copy this and I'm going to go back and paste it here. Next, it's going to ask me for AWS secret access key, which is this one here. I'm going to copy this, paste it here. Then it's going to ask me for default region name, US East -1. And then it's going to ask me for default output format. I'm going to use JSON for this. So that's it. That's your basic configuration. Next step is basic AWS CLI commands. Let's look at some of the commands. So if I want to see all the S3 buckets, I can say AWS S3 ls. And since I have not created anything, it's going to give me empty. Next, let's clear this out first. Next, I want to launch an EC2 instance. AWS EC2 run -instances -image ID, the image -id, and I'm gonna give the name image ID, which is AMI, let's say 1 2 3 4 5 6 7 8, whatever it is. And I'm gonna say I want to create one instance, and then what instance type I want. Instance type is, let's say I want t2.micro, and then if what is the key name, key pair that I want, so that is by key --key -name, and let's say my key pair is what I want to call it. So this will launch an EC2 instance for me. And if you see an error occurred while calling run instances operation, the image ID does not exist. So since we have not created this AMI, it will give me this error. But we'll look at it in our hands-on experiment on how to do this. You can look at all the other commands in the documentation for AWS CLI. So that kind of gets you ready for our hands-on project, and we have set up our AWS CLI on your machine. If you have any issues, let me know in the comments and I'll get back to you. Let's jump into the hands-on exercise for using the AWS CLI to launch and manage EC2 instances. In this particular case, we're going to just follow these steps where we'll initially set up AWS CLI. If you didn't do it in the previous section, you can do it here. Then launch an EC2 instance. Then we're going to look at check the status of the instance from the CLI. Then we'll SSH into the EC2 instance. We'll look at stopping and terminating the instance. And finally, we'll look at automating EC2 instance launch with a shell script. So let's get started and dive in the hands-on exercise. So let's begin. In this hands-on exercise, you will learn how to use the AWS CLI to launch and manage EC2 instances. This process demonstrates how to automate resource management using command line tools. So first step, which is set up AWS CLI. Now before you start, ensure that you have installed and configured the AWS CLI with your AWS credentials. We did that in the previous step. So if you have not yet, go through that and make sure your AWS CLI is installed. Next step is launch an EC2 instance. Now first, we have to, if you remember, when we created our EC2 instance in the previous section, we went ahead and we said launch instance, and here we gave the name, we selected what type of AMI I want, we went to the instance type, we created a key pair, we also created security groups. So that was all created for us automatically. But what if you want to do this using command line? So let's go ahead, and first step is identify the Amazon machine image or AMI that you want. For this example, let's use the this one, Amazon Linux AMI. Now to run this AMI, we can use this AMI ID here directly, or we can run this command AWS EC2 describe images owners Amazon dash filters that I need to use to describe the different images, where I'll say name equal to name, and values, the ones that I'm interested in is AMZN dash AMI dash HVM. These are the Amazon Linux machines. Dash star dash AMI dash, I think it's X underscore 86 is X86 underscore 64 dash GP2. If you look at this one here, probably will have the same form kind of filter. So this will just give me an error here. Let's try one more time. What did I miss? Oh, instead of C2 is what I wanted to say here. I said EX2. Run this, and we'll get our AMI image ID. So there's an AMI image ID here. This is what I'm interested in. It will show me all the different ones. So I'm going to just make sure that I can just pick it up from here. If you see here, it's available here too. So I can just use this here, this image ID. So just take a note of this here, and then I'm going to just quit this here, clear this. So now I have my AMI image ID that I want to use. Next thing I want to do is launch the EC2 instance. Now use the following command to launch an EC2 instance. So first step, the actual command is AWS EC2. This time make sure there's no typo. Run instances is the command, and inside here I will pass the image ID for the AMI. And now if you remember your AMI ID, or I can just get it out down from here, which is AMI dash 0182 F373 E66F89C85. That's my AMI image ID. And next, so depending on what it shows on your interface, you can use that, or you can just use it from above when we gave the command to list all of them. And instance type that I want, which is instance type here, is what I'm going to select. Instance type, okay, let's make sure I have my, is T2 dot, I'm going to make it a little bit dot micro. Next, it's asking me for next thing that we want to give is the key name, which is the key value pair. Now for this, I have not created a key value, or I don't have any key value pairs right now, if you look at it. So what I can do is I can create a key value pair. I can say create new key value pair. I'm going to give a name here. I'm going to say my key pair, RSA PAM create key pair, and it asks me to download. So once it's downloaded, I'll make sure that is available. So that name is my key pair. So I'm going to go back here. I'm going to say give the name my key pair. In the previous section we created a key pair. If you want to use that one, you can use that. And then finally I need to provide the security groups that I want to use for this. So I am going to call it my security group, which I have not yet created. So make sure that your image ID is whatever image ID, the ID of the AMI to launch. Make sure your instance type is T2 micro for free tier, and key name is the, the name of the SSH key that you created. And for security group, we'll have to create a security group that can be used here, which is in this case I've created this my security group which doesn't exist. So what I'm going to do here is I am going to go to the security group section, and I'm going to create a new security group, and I'll say the name of this particular security group, let's go here, my security group, allow SSH access to developers, this VPC, use that, all traffic, whatever it is, leave it that way, create the security group. Allow SSH access to developer. This is just a description, so I can just say my security group for AWS CLI. So create security group, and it will create my security group, which is called my security group. Now I can go back to the AWS CLI and run this command. So this command will return details about the newly launched instance, including the instance ID, which is inside here, instance ID. This is the instance that it created. Now if you want to check the status of this, I can copy this here, clear this out, and to check the status if it's running or not, you can say AWS EC2 describe instances, instance IDs, and pass the instance ID of that you copied. Will run and will give you the status of that particular instance of what all different things it's using. You can just go through it and you'll say state is running. I can always go here and go to the EC2 dashboard and look at my instances, and if you see this one, just quit, and you see I0020, this is the one that is running right now. That's the only one that I have because I've deleted everything before. So now you've successfully created a EC2 instance using AWS CLI, and you have also from our steps check the status of the instance. Next, SSH into the EC2 instance. Now we have done this before where we have SSH'd into the EC2 instance. So what I'm going to do here is I'm going to run that same command again. First, let's clear this out, and I'm going to say SSH -I. This was our hands-on in the first chapter. Now I have, let's see, let me go to desktop if I'm not on desktop, and on that I have that my key pair that we just created, and I'm going to go there and say this my key pair .pem, and I want to say ec2-user, that's my username, at, now this IP address that I probably could have gotten it from the description, but I'm just going to go and jump into my instances here, and then if you even here once you're in this instance, you can go to connect and you can get the SSH command here. See, this was my address, and I can just put it over there and run it. I think I forgot to do the chmod, which I also did in the previous one, so it might not work. So I'm just going to kill it before even it gives me an error, and make sure that I give this error and give this command. So that's good, and then I'm just going to copy this here. So it's going to ask me to continue this, so I say yes, and it will give me access to the SSH. Now this was pretty straightforward because we've done this before. Now that I have access to this, you can go ahead and run your commands directly on this particular EC2. I'm going to exit out of here and clear it out, which kind of completes our step 4, which is into EC2 instance. Next thing is stopping and terminating the instance. So what I can do here is I can go and say AWS EC2, and I can say stop instances. Let's make sure it's running. So I'm going to go back to let's go back to EC2 dashboard. I have this one instance which is running. Now I'm going to go here and say stop instances, instance IDs. Now I've copied that before, but I don't know if I still have it. So I'm going to copy it from here, pass this here, and it says stopping instances. This is the one that is going to stop. So I'm going to go back here and refresh this, and you can see no matching instances found because I'm looking for running. If I remove this, refresh it, and you see it's stopping. So it's stopping that particular instance. Now if I want to completely get rid of this particular instance, I'll use the same thing, AWS EC2, and I'm going to say terminate instances. I'm going to just copy it from here. It's the same code, but I'm saying instance ID. This is the instance ID that I want to terminate. And run that, and it's just terminating instances, and it's going to say shutting down. So let's refresh this again, and if you see, shutting down. So this is how you can stop and terminate the AWS instances from AWS CLI. And finally, let's look at automating EC2 instance launch with a shell script. So in this case, we've seen all the commands that we did. You can do the same thing using a shell script, where you can automate the process of launching an EC2 instance using a simple script. Here's an example script. I can just create a sample one and show you. So I am gonna say, so this is a bash script. Usually bash script starts with something like this, bin/bash, and inside this you'll have to define the variables that you need. For example, I'll say image ID is equal to whatever the AMI ID that you used. So you can give that here. Next, instance type. This is another variable that I like to define, where I always say t2.micro if I want to use the free tier one. Next is key name. I'm going to use the one that we created, which is my key pair. The security group that we created, I'm going to give that one equal to my security group. So these are some of the variables that I create. And now to launch an EC2 instance, if you remember that command, we can always go back here, run instances, this one, copy this, paste it here, AWS EC2 run instances image ID. Now this, you can always use it here, and can take this and put it here saying $image ID. That's how you give variables. Instance type, I can, instead of using this, I can use the $, and then you can, for instance, sorry, I gave the instance type. Key name, you can give that key name that we created here, $key name. Security group, pass that security group here, and then I can just say echo EC2 instance launched successfully. So this can be my bash script. I can save it to my script here, and if I want to run this script, I can just go here and say, let's see the script here. So the script, I forgot that I need to name it as .sh. Add, perfect. Let's see now, and I can say .sh. Bad interpreter, no such file or directory. To have that, oops, sorry, /script. So I ran the command, the bash script, and ran my script and created an EC2 instance. Now if I go to my browser here, refresh it, or refresh it from here, I'll probably see one more. This was terminated because I just killed it previously in the previous example, and this is the new one that is running right now, which we created from the bash script. So this is an example of how you can create or automate your EC2 instance launch with a shell script. So that kind of wraps up our second chapter, and if you have any questions, let me know in the comments and I'll get back to you. Thank you. AWS Identity and Access Management. Welcome back. In this particular video, we will be looking at understanding IAM users, groups, roles, and policies. Then we're going to jump into creating and managing users and roles. We'll look at some of the best practices for securing AWS resources. We'll do a hands-on of creating an IAM users and assigning specific roles and policies. And we will start our first project, which is building an IAM policy to restrict access to S3 for specific users. Let's get started. First topic, understanding IAM users, groups, roles, and policies. Now, AWS Identity and Access Management, also called as IAM, is the service that allows you to manage permissions and control access to AWS resources securely. By configuring IAM, you can define which users or services can interact with specific AWS resources. Some of the key concepts here are IAM users. A user in IAM represents an individual person or application that interacts with AWS resources. Users can have credentials such as a username, password, or access keys to access these AWS services. Users can be assigned permissions via policies. Next, we have IAM groups. Groups are collections of IAM users. Policies applied to groups are inherited by all the users in that particular group. For example, you might have a developers group that grants access to EC2s and S3 services. Grouping users simplifies management by reducing the need to assign policies individually to users. Then we have the IAM roles. Roles are used to grant permissions to AWS services and resources without needing long-term credentials like access keys. IAM roles can be assumed by AWS services, example EC2 or Lambda, enabling them to interact with other AWS services like S3 or DynamoDB. Roles are useful for cross-account access and for managing permissions for applications running on EC2. And IAM policies. Policies are JSON objects that define what actions are allowed or denied for specific AWS resources. Each policy contains statements that describe permissions in terms of first effect, either allow or deny. Then there's action, the specific AWS action, example S3 list bucket, which will list buckets for the user, or EC2 run instances, which will let the user or policy or group or role to run instances. Then resource, the specific resource to which the policy applies, example a specific S3 bucket or EC2 instance. I'll show you an example in a minute. Now policies can be attached to users, groups, or roles. Here is an example on how a policy, basic IAM policy looks like, which allows read access to an S3 bucket. If you see, I've given the version number statement where I have effect, action, and resource. Effect is allow permission. Action is you can get objects from that S3 and you can list buckets from S3, and the resource is the example bucket that I've created. Creating and managing users and roles. Now how to create IAM users. We're going to jump into doing this, but before that, let's look at just a brief overview. So if you have to create a new user, in AWS Management Console, we'll go there, we'll go to IAM and then click on users and then add user and define some username. We can choose the type of access, which is programmatic access. This option generates an access key for using AWS CLI or SDK. And we have AWS Management Console access, which allows the user to log into the console. Then we also have like assigning permissions. On the next screen, once you create this user, you can attach policies directly to user or add the user to a group. Best practice would be use IAM groups to assign permissions instead of attaching policies directly to user. And then finally, you review and create. After reviewing the configuration, you click the create user button that will be available. Provide the user with the login credentials, either access keys for CLI API access or login URL for console access. Also, we'll be creating IAM roles where you create a new role where you can go to IAM and roles and create a new role. You choose the AWS service that will assume the role. For example, if EC2 needs access to S3, select EC2 as the trusted entity. Then we are going to attach the policies where you'll attach policies to define the permissions this role will have. For example, grant the role access to an S3 bucket, and then we will assign role to the AWS services. After creating the role, assign it to your EC2 instance or Lambda function. Now let's jump into the hands-on for creating IAM users and assigning roles. Let's start creating IAM users. To create a new user, first let's go to the IAM section. So I'm at the IAM dashboard. It asks me some security recommendations which we can ignore right now. But here I can start creating IAM users by selecting users and then create a user. I will create a user with username Vivian Arana, and here it is asking me to provide user access to AWS Managed Console, which is optional, but I want this to be a programmatic access user. The programmatic access option generates an access key for using AWS CLI or SDK. So I'm going to keep it this way, username, and then it will give me options to add user to a group. If there is a group, I can add that user to a particular group, but it says create group, which means we don't have any groups right now. Copy permissions. If you want to copy permissions from existing permissions, you can do that. You can attach policy directly. So there's a lot of different, like if I want to give the user S3 read only per access, I can just select here and give it right now, but I'm not going to give any permissions, anything. What I'm going to do is I'm going to just go ahead and say next in this particular case, and I have my user details here. Console password type none, request password reset none. I'll give the CLI permissions in a minute, and I'm going to say create user. Now the user is created, is not added to any group, doesn't have anything, any access. I'm going to select the user, and here I can add a group to the user. Now there's no groups, so let's create a group first. Add user to a group. Create group, and in this particular case I'll call this group S3 access, and I'll give S3 read only access to this particular user. Create that user group, and that's done here. And I am going to select that group, and I'll say add user to this particular group. So now the user is added to that particular group. Now let's see how we can give the user access to login. So if you see console sign in, so this is where the user can sign in. I'm going to say enable the console sign in, and it will ask me auto generated password or custom password. I'll say auto generated password, enable, and it will create this console username password. I can download this CSV file and share it with the user that I have. Close this. Another thing, I can also create access key for this user so they can programmatically access the CLI. So I'm going to say create access key, command line interface. I understand. I mean, there's a bunch of different options you can give them, but I'm just going to do that. Next, description tag, I'm going to say my IAM test user, create access key, and it does this, and I can pass this options to the user too. Done. Now let me make sure that I download it and share it with the user. Done. And that takes care of giving user credentials and access to the console sign in. So that's all we need to do here. Perfect. Now let's go back to the users. Click on him again one more time. Let's look at permissions, part of a group, so that permissions are added there. Tags, we've created a tag over here, my IAM test user. We've given security credentials. So this all works fine. Now next part, which is creating IAM roles. So I'm going to go inside roles, and here you can create IAM roles by clicking on create role. I'm going to select AWS service that will assume that particular role. For example, if EC2 needs access to S3, select EC2 as the trusted entity. So here I can service or use, I'm going to say EC2 is what I need. Next, and here the policies are available, and I can say that I want to attach a policy to grant role access to S3 bucket. So I'm going to say S3, say allow S3 full access. This is how I can provide access, and assign role to the AWS services. After I am done with this, next, role name, I'm going to say S3 access for EC2, allow EC2 instances on your behalf, and Amazon S3 full access, and I'll say create a role. So this is how you can create a role, and it's available here. You can go click on this and look at what permissions it has. You can look at trust relationships. We have tags, access advisor, and revoke sessions. So if there's an active sessions, you can revoke those sessions from here. So how do you use this role to assign to an EC2? So first what I'm going to do is, let's go to EC2, and my EC2 doesn't have any instances running. There's an instance running, but I think it's an instance that we terminated. So I am going to go to instances and say launch instances. I'm going to give it test IAM instance. I'm just going to create it just to test it out. Use the basic stuff. Select key pair. I don't have a key pair, so I'm going to say create a new key pair, test key pair, because I'm not going to use this. Create key pair, leave everything default, and I'll say launch instance. It's going to launch this instance, and now I want to assign that role to this particular instance. So I'm going to go to the instances. Let's see, refresh, and the one that is probably this one, which is not yet started up. I'm going to refresh it, and now it's running. So I'm going to select this instance, and inside this I'm going to look for where I can assign a particular role. So you can select in actions here. You can just go click on security and say modify IAM role, and here I can look for that S3 access for EC2 IAM role, update the IAM role, and that is assigned to this particular test IAM instance role. So this is how you can assign roles to your EC2 instances. Now EC2 can access that S3 bucket on your behalf in this particular case. If you have any questions or had any issues doing this, let me know in the comments and I'll get back to you. Best practices for securing AWS resources. Now, securing your AWS environment with IAM is crucial for minimizing the risk of unauthorized access. Here are some of the best practices. First, enable MFA for privileged users. This multi-factor authentication, MFA, provides an extra layer of security. Enable MFA on the root account and for users with high-level permissions, example admin roles. In our example, we have in our previous videos, we have not done this because we are not using this for real purposes. We are just using the AWS account just to learn these things, but it's the best practice to enable MFA for privileged users. Follow the principle of least privilege. Always assign the minimum permissions necessary for users or services to perform their task, and regularly review and audit permissions to ensure users or roles are not overprivileged. Avoid using the root account, and that's one of the best practice, and we've been using root account constantly. The reason is, again, we are doing this for tutorial purposes. The root account has full control of your AWS environment and should only be used for critical tasks. Creating individual IAM users for daily operations and secure the root account with MFA. Rotate the credentials regularly. Rotate access keys and passwords periodically to reduce the risk of compromised credentials. Use AWS Secrets Manager or AWS Systems Manager parameter store to manage secrets and rotate them securely. Use IAM roles for applications. Instead of embedding access keys in your application, assign IAM roles to AWS resources like EC2 instances or Lambda functions. This avoids the risk of exposing long-term credentials. Audit AWS IAM with CloudTrail. Enable AWS CloudTrail to track all IAM related activities such as user logins, role assumptions, and policy changes, and regularly review the logs for suspicious activities. I know a lot of things that we covered here, we have not yet looked at them, but we will be learning them as and when the video progresses. Hands-on. This is our hands-on exercise where we'll be creating IAM users and assigning specific roles and policies. So in this particular exercise, we'll create IAM users, assign roles and policies, and explore different permission configurations. What we will be covering here is creating a new IAM user, assigning specific policies, and test permissions. So let's jump in and start with our hands-on exercise. So first step is to create a new IAM user. So I'm going to go to my AWS Management Console, go to IAM. I have cleared out all the users, so it's like starting from blank. Create a user, let's say create user, and next. I am going to, in this particular case, let's say create a group, and in this particular group, I am going to give him access to S3 read-only access. So I am going to call this S3 read-only access, S3 read-only, create user group. So I have that S3 read-only access. Next, and in here I don't want to do anything. Review, create, and my user has been created here. Now I have to give this particular user access to CLI, SDK, API, all those things. Go to security credentials. I'm going to say enable console, enable. It's going to download, close, and I'm going to give create access key. So I'm going to say create access key, command line. I understand. Next, this create access key. So I've created the access key. I'm going to open terminal and quickly configure for this user. Configure. I need access key. I need to change the access key to this. Secret key, copy, and default region, that's fine. Default output format JSON is fine. So I've created that. Now next, I am going to make sure that there is a S3 bucket available for us. So I'm going to jump to, okay, let me make say done here. Now let's download this just in case, done. And I'm going to go to S3 buckets now, create a bucket. Create a bucket called say IAM test bucket. It doesn't give any problem. ACLs, all these things, create a bucket. And I think I forgot something. Oh, this thing is already exists. Bucket test. Okay, that's fine as long as I can create one. So IAM test bucket test has been created. I can go inside this. I can upload some files here. Say upload. I can open my finder. I have a test.py file which I can just drag and drop here, and that's the file that I want to upload. I'm going to say upload, and it will upload the file. So my IAM bucket has a file. Close. I'm going to try to go back to this here, and I can say AWS S3 ls. It will say that when calling the list buckets operation is not authorized for S3 list all buckets because no identity based policy allows. So that means we have to do that other thing, which is assign specific policies. So what I'm going to do is next is I'm going to assign the specific policies. So I'm going to go back to my browser here, and I am going to go back to IAM. In here, go to policies, create a policy, and this policy that I am going to use, we've done this before using Visual. Let's do it one with JSON. So in here, version statement allow, and what do I want to allow here? I want to allow an action which is S3 list bucket, and I want to do S3 get objects. So I can get objects from that particular bucket. So those are my actions. Resource. Now I need to get that resource. So what I'm going to do is, without even closing this, I'm going to say open in new tab, open S3. I want to get the ARN for that. I can go to properties for the bucket, and here is my ARN. I'll copy that, go back, and in the resource I'll paste that ARN. So I have access to that particular bucket. That's what it says. Let's say next. Policy name S3 test policy. Don't have to add anything here. I hope that is not take. And say create the policy. So now that policy is created. Once the policy is created, I can go to that particular user and say I want to add a permission. I can create inline policies too here, but it's always better to create a policy so we can give access to users. So I say attach policy directly, and the policy that we created was something with test. So here is the S3 test policy. Say next and add the permission. And now that user has the permission to list and get objects for a particular bucket that we created. So now we're going to go back to the terminal and see if that worked. It says access denied. It takes some time sometimes, so I'm going to clear it out. Try again. Oh, the problem here is I am trying to list all my buckets. So let's try to list only the bucket that we're interested in, which is S3:/ and my buckets. This is the name of the bucket. And there you go. I can list the contents of this bucket right here. If I remove that again, just to test it out, if I remove this policy from the user, let's see, permission policies, remove policy, clear it out. Let's run this again, and you see error occurred. So because I removed the policy, the user cannot access it anymore. So that's how this works. So that kind of got us through the first. We created a new IAM user, we assigned specific policies, and then we tested the permissions by adding and removing the policy. So if you have any questions or if you had any issues, let me know in the comments and I'll get back to you. First project, build an IAM policy to restrict access to S3 for specific users. In this particular project, the objective is you will create a policy that restricts access to specific S3 buckets for particular IAM users. This is a common use case where certain users should only have access to specific buckets within an AWS account. First, create a custom IAM policy, then assign the policy, test the policy, and finally audit the activity. So let's get started with building this project. So create a custom IAM policy. I'm going to use whatever we did in the previous section for hands-on and continue from there. So it says create a custom IAM policy. So first, I'm going to create a custom IAM policy where what we mentioned was we will make sure that a particular user or this policy has full access to one S3 bucket and denies access to all the other buckets. So what we're going to do here is I am going to create first, let's create some S3 buckets. We have one already, which is IAM test from our hands-on that we did. I'm going to create another. This one should be forbidden. And I'm going to create this bucket. I'm going to say don't touch this. Create another bucket. Don't touch this. Create that bucket. Buck. Don't touch this buck since it's already name is already taken. So I have three buckets here. This one should be forbidden. IAM test bucket test. Don't touch this bucket. Now currently our user, if you remember from our last step, I am saying ls s3, he can't access this. Let's see what else can he. If I say list all the buckets, he can't see anything. There's no list all my buckets access to this user. So let's create the policy first. So I'm going to go to IAM, and here I'm going to create the custom IAM policy. Let's say policies, create a policy, and I'm going to go with JSON again, just so that it's much more easier to look at. I am also trying to open that S3 in a new tab so I know the names or addresses of those, or resource addresses. And here I am going to first say allow. The first statement is allow, and inside this the action should be, I'm going to go ahead and say S3 list bucket. That's for listing the buckets. And if I want to get object from there, I'll say S3 get object. That's the next one. And if I want to put stuff in there, so I want full access, so I'm gonna say put object. So I have all three options here, which is S3 list bucket, S3 get object, and S3 put object. For which resource? Let me add that resource name. I am the test bucket test, and properties, I can copy this here, and here I will say this is the location of the bucket. And if you want to give this to all the items inside there, you can say slash star, so whatever is inside that bucket you'll have full access to that too. So that takes care of that. Now next thing is to deny access to everything else. So here I am going to create another statement. I'm going to copy this thing here just so that, and this one I'll name it as statement 2, and here I'll say deny, and my action will be, in this case, instead of an array, I am just going to say I want to use S3 star everything. So they actually go in order. So if the first one says allow to this bucket, and this bucket with these access, this will take place first, and then it will look at this. So if it's only specific to one bucket, when it's accessing the second bucket, it will look at the second statement and see that I am saying deny to all the resources. And here inside my resources, I am going to say, instead of this, I'll open the array, and here I'll say ARN AWS S3 star, which means everything. That's closed, and I can also do the same thing for the content inside here. S3 ARN AWS S3 : star / star. So all the contents too, not just inside. Now in here I will also add a condition, and for that I can say condition. The condition that I want is string not equals and S3 prefix is not equal to our bucket that we have. So that's IAM test bucket. So except for this bucket, everything else is denied. So that's how you can create a policy here to do what we wanted to do. And say next, policy name, I'll say test project 2. It has my limited list read, create the policy, and my policy is created. Let's look at it if it exists. Test, there you go, test, which one was test project 2. This was our project's policy that we created. So what we did right now was created a custom IAM policy. Next type is assigning this particular policy to a particular user. So we have a user here. I'm going to say user permission here. So I'm going to say add permissions, attach policy, and the policy is test project to next, add permissions. So I've added that permission, and now once I've added that permission, I think we should be good to go. Let's go back here. Next is test the policy. So let's test it out. I am going to go here and say it's going to give me access to that particular bucket. Whereas if I try to give the other bucket name, which was do not touch this bucket, it will say error occurred. At the same time, this one is forbidden, or whatever that name was, it will give me an error. So what we did over here was we went to created a custom IAM policy, assigned the policy to a user, we tested the policy, and for audit the activity where we'll be using CloudTrail, we'll probably leave it for later when we are actually have done something on CloudTrail. So I'm going to stop it here and we can jump into the next section. If you have any questions or any problems that you faced, let me know in the comments and I'll get back to you. Welcome back to Amazon EC2 virtual servers in the cloud. Here we will cover launching and configuring EC2 instances. We'll look at understanding instance types, pricing models, and key pairs. We'll do a hands-on exercise on deploying a web server on EC2. And finally, the project 2, which is automate EC2 instance creation using a startup script to install and configure a LAMP stack. So let's get started. First, launching and configuring EC2 instances. Now, the Amazon EC2, which is Elastic Cloud Compute Cloud, is a web service that provides resizable compute capacity in the cloud. It allows you to launch virtual servers, which are instances, on demand, configure them as needed, and scale them up or down based on your requirements. Here are the steps to launch the EC2 instance. We've done a couple of times before, but we'll go through them quickly. First, access the EC2 dashboard. Click on the launch instance and choose an Amazon machine image AMI. The AMI is a pre-configured template that contains the operating system and any additional software, example Amazon Linux, Ubuntu, Windows servers. For most Linux-based projects, the Amazon Linux 2 or Ubuntu AMIs are commonly used. Next, choose an instance type. AWS offers a variety of instance types optimized for different use cases. For example, choose T2.micro for small, cost-effective instance eligible under the AWS free tier. Configure instance details. You can configure options such as number of instances, launch multiple instances simultaneously, networking, where you can choose the VPC and subnet for your instance. You can also do auto scaling, where you can configure auto scaling options if needed. You can set up IAM roles, where attach IAM roles to provide the instance access to other AWS services, example S3 or RDS. Add storage. By default, EC2 instances come with EBS volumes, which are the Elastic Block Store, providing persistent storage. For example, you may configure an 8 GB root volume or add additional volumes if needed. Configure security groups. Security groups act as a virtual firewall for your instance, controlling the inbound and outbound traffic. You need to allow specific traffic, example SSH on port 22, HTTP on port 80 for web servers. Best practice, restrict SSH access to your own IP address for security. Next, review and launch. Once you're configured the instance, review all settings and click launch. Choose a key pair. AWS uses key pairs, which are public and private keys, to securely connect to instances. Either create a new key pair or select an existing one, then download the private key, which is .pam file. This will be used later to SSH into the instance. And we have seen a couple of times when we built this in our previous hands-on or projects, how this was done. Finally, launch the instance. After selecting the key pair, click Launch Instances to spin up your EC2 instance. And we'll be covering this later when we build our project. Next, understanding instance types, pricing models, and key pairs. Now, for instance types, EC2 offers a wide range of instance types that are optimized for different workloads. They vary based on CPU, memory, storage, and networking capacity. Some of them are the general purpose instances. Examples are the T2 micro, T3 medium, M5 large, These are balanced for compute, memory, and network resources, making them suitable for a wide range of applications. We also have compute optimized, which examples are the C5 large or C6G.X large. These instances offer high CPU performance for compute intensive tasks like gaming servers, high performance computing, and scientific modeling. Memory optimized. Examples are R5.large and X1.32X large. Ideal for applications that require a lot of memory, such as in-memory databases, analytics, and big data workloads. Storage optimized. Examples are i3.large or d2.extra large. Designed for applications requiring high input-output operations and large storage capacity, such as NoSQL databases or file storage systems. Next, let's look at the pricing models. We have the on-demand instances. You pay for compute capacity by the hour or second, depending on the instance type. There is no upfront cost, and instances can be terminated at any time. It's suitable for short-term, unpredictable workloads. Next, we have the reserved instances. Provide significant savings up to 75% over on-demand pricing in exchange for committing to a 1 or 3 year term, best for steady state or predictable usage. We also have the spot instances. Spot instances let you take advantage of unused EC2 capacity at a reduced cost, up to 90% of the on-demand price. Best for flexible applications that can tolerate interruptions. Examples are batch processing or big data analysis. And finally, we have the dedicated host, a physical EC2 server dedicated for your use. This is ideal if you need to use your own licensing or to meet regulatory requirements. Next, we have the key pairs. Now, key pairs are used for SSH access to your EC2 instances. When launching an EC2 instance, you are prompted to create or use an existing key pair, which kind of consists of the private key, the file you download when creating a new pair, which is .pem file. This is used to authenticate SSH access. And we also have the public key, which AWS stores the public key, and it is associated with the EC2 instance you launch. Let's dive into the hands-on exercise for deploying a web server on EC2. In this, we will be doing a few steps like launch the EC2 instance, connect to your EC2 instance. Next, we'll be installing an Apache web server, and then we will be configuring the security group. We will test the web server and see if everything works fine. So let's get started and jump into the hands-on exercise. So let's start with the step number 1, where we are launching the EC2 instance, and connect to your EC2 instance is step number 2. So I'm going to go open my AWS Management Console. I'm going to launch an instance. In here, I'm going to call this one my test EC2, and then I'll make sure I select the Amazon Linux, free tier eligible, make sure T2 micro, key pair, I'll say create a new pair. I am gonna do this right now, my key pair. I'm going to also save this for the next project that we're going to do, which is the actual project, not the hands-on. Say create key pair, it will download it, and then let's look at network settings. Everything looks good. I'll also say allow HTTPS, allow HTTP for traffic, because we will be creating the web server. Rest of things I'll leave as it is and say launch instance. So this is our step number 1, launch EC2 instance. Next, connect to your EC2 instance using SSH. I'll go back here and I'll go back to my instances, and I'll only want to see the running ones. So this is the one that we just created. I'm going to select this. I'm going to say connect. It will open my SSH client option here. I will make sure, let's open this terminal and let's see if my key is here. My key is here. I am going to make sure it has chmod. Perfect, that's done. And next, try to connect to it. Copy this, connect to it. I'll say yes. And I'm connected to that particular EC2 instance. So perfect. What is the next step? Next step is install Apache web server. Now this is something that we've done in one of the samples before, so I'll follow the same steps. First step is sudo yum update -y, so update the libraries. Next I'll say sudo yum install httpd, that's the Apache server, -y. So it's installing now. Next what we'll do is we'll start the Apache server. Now to start that, you'll say sudo system control ctl start start httpd. That will start the server, and then now I need to enable it. Sudo system ctl enable httpd. So if the server shuts down, it automatically restarts it. So that's been created, and now I can go to my browser, see where my instance is. This is my, let's hit open again, only the running ones that I'm interested in, which is this one, and I'm going to open the public IP address, which is 3. Go open this, and it says it works. Now make sure your HTTP connections are in here. Make sure, if sometimes some of the issues that we heard of was they were not able to open this, so make sure that you, in your security group, you have your HTTP bounds here. The way to actually look at it is you can go to your security groups, select the security group that you have. Let me see, I think the one that we added was this one, using the launch wizard, so I'm going to click on that, and inside here you make sure that you have that. If it's not there, you can always add one like this, saying HTTP. We did this when we launched the system, but this is how you can do it. I'm not going to keep it, I'm going to delete it because I already have it. So this is how you can add your rules to make sure that the inbound rules have traffic from HTTP. Next, is there any more steps? So we have tested the web server also by going to the browser, and we know that it works, so that's perfect. Project 2. Automate EC2 instance creation using a startup script to install and configure a LAMP stack. In this project, we'll automate the setup of an EC2 instance with a LAMP stack, where LAMP stands for Linux, Apache, MySQL, and PHP, by using a startup script, also known as user data, during instance launch. So the objective here is automatically launch an EC2 instance and configure it to run a LAMP web server without manual intervention. The steps that will follow is, first, create a startup script with the user data. The user data script runs automatically when an EC2 instance is launched. It is typically used to automate instance configuration tasks such as installing software. Next step is launch the EC2 instance with user data. Then we'll go into connecting to the instance and testing the LAMP stack. Then we'll do automating the EC2 creation with the AWS CLI. So that will kind of cover our project 2. So let's dive in and do some hands-on for this project 2. Let's start with step 1, where we have to create a startup script. So we're going to start and create a startup script. This is a script that is a bash script which can run automatically. So I'm going to call this script.sh and save it on my desktop for now, so we can see, and you can write it as and when I go. So first thing that we did in our EC2 instance was here, sudo yum. So instead of doing this manually, I can automate it using a script. Next thing that we did was install httpd. We'll do that, and then we started the httpd, so that's the next step, and then we enabled httpd. So I'm going to just copy. So this will, if I run the script directly, it will create an Apache server automatically, even me going inside EC2. So how to do that? So we'll look at that in a minute, but let's complete it. What else do we need in our script? So this is a LAMP stack. So we need, we already have, it's a Linux machine. We have Apache server running on here. Now we need MariaDB. So we will say sudo, the MariaDB command is sudo yum install. We'll have to specify what servers we want. So it's MariaDB Current version is 105 server dot x86 underscore 64. That's what I need. Next, I'll say sudo. It's the same thing as this, but I am enabling MariaDB, MariaDB, and then I need to start MariaDB. So I've started that. Next, I need to install PHP because LAMP, the last part is PHP. So I'm going to say yum install -y PHP, and then I'll have to restart the Apache to load PHP. So since I've already started it, I'll say systemctl restart httpd, and then I want to create a file just to check if everything worked. So I am gonna say question mark some PHP here, PHP info, which will give me information about the PHP version and all the things that I can do with this PHP file. This is, if you've never used it, just copy it as it is. And I want to write that to my var www html/info.php. Sometimes it will not give you access to write to this file. So to do a good practice, what you can also do is chmod 777 to this particular folder, so you can execute this command over there. So this is my startup script. That was the first step, and it says user data. What does this mean? So what I can do is I can go to my server here, to my instance. Now saying instance is running is 0, but I have one instance running. Usually what you can do is you can, while you are creating an instance, and if you have a startup file, you can go to the bottom in the advanced details. There is user, there you go, at the bottom of the screen in the advanced section, there is a place where you can upload that script file, or you can even copy paste the entire thing here, and it will run it as soon as it starts the server. So that's one way of doing it. But what if you have a server already running? For example, in our case, we already have a server running. Why not use that, reuse that? So you can go to that particular instance. First of all, you'll have to stop the instance to put a script in there. I'm going to stop that instance, make sure it's stopped. Let's go back here and let's see if it's stopped. I'm going to open this now. It's still saying stopping. I can go to the instance, and in actions can always look at right instance settings. I can go here and I can say edit user data here, and if there was a data that you added before, it will be there. If you want to modify the user data as text, you can just copy this and paste it here. So I've added the entire script here, and I'll save this file. Now what will happen is, now when I start this server instance, it will run that script because that's the user data script that I've written. So that's what our step is, to launch the EC2 instance with user data. So I'm going to launch that right now here by saying start instance. So it will take a few seconds to run again. There you go, it's saying it's running, but it's going through all those commands that I wrote, which is update, install the Apache server. It will take a few seconds, so it will not take much time, but it's also going to switch off that install PHP, switch off that Apache server, and restart it and run it. Now the next step in this particular case is connect to instance and test the LAMP stack. So to test if the instance is running, what I'm going to do is I'm going to open my browser, go to this particular, let's refresh, make sure it's up and running. I'm going to go to the address which is already running. They should be fine, but I've also added, if you remember, I added a file there which was info.php. so just go at the end and say /info.php, run it, and there you go. It loads up your PHP info file right here and tells you that everything is in place. Perfect. So that kind of got us from creating a startup script, launching the EC2 instance, connecting to the instance, and testing the LAMP stack. So it's all working. We have Apache server running, which has PHP installed in it. We have MariaDB in there, which we installed using the script, and it's running on a Linux server. So the next thing that we want to do is automating the EC2 creation with AWS CLI. I'm going to open my terminal, open a new instance, and now I'm going to go to desktop. Now to do this, where I am automating this process from my desktop itself, I have the script file here. If you look at it, I have the script file here. The way to run it from my launch an instance with all these things is you can just say AWS EC2 and then run instances. That's the command. You can give the next line, and in my next line I can say dash dash image dash ID AMI-ID. So here I provide the AMI ID that we have. Next, I will say instance type that I want to use is the, let's say, t2.micro is what I want to use. Next, I want to give the key name. So I can say the key name, in our case, it's the key pair that we have. So I can say my key pair, or whatever name you have given to that particular, give that file name. Security group, next is security group. The name of the security group is what you provide here, sg dot whatever that ID is, and finally you provide the user dash data and path to my script.sh. So I can just say script, since it's here, .sh, script.sh file. So this is what I can run directly from here. If I know the AMI IDs and my key pair and security group ID, I can directly create an instance and run with all this code right from my command line. So this command automatically launches an EC2 instance and runs the specified startup script to install and configure the LAMP stack. So there you go. That completes our project 2, where we automated EC2 instance creation using a startup script to install and configure a LAMP stack. If you have any questions on this, let me know in the comments and I'll get back to you. Thank you. Amazon S3 Scalable Storage. In this particular section, we are going to look at Introduction to Amazon S3 Buckets and Objects. We'll go over managing permissions and storage classes. We'll do a hands-on exercise on building a simple S3 based file upload app, and finally we'll do a project 3, which will create a static website hosted on S3 with custom domain and security settings. So let's jump into it. First, introduction to Amazon S3 buckets and objects. Amazon S3, also called as Simple Storage Service, is an object storage service that offers industry-leading scalability, data availability, security, and performance. It is designed to store and retrieve any amount of data at any time from anywhere on the web. Some of the key concepts for this include buckets. Buckets are containers for storing objects. Each object is stored in a bucket, and every bucket is created in a specific AWS region. Bucket names must be globally unique across all AWS accounts. And sometimes in our projects where we created buckets, you saw in our previous examples where we tried to give some name which was already taken by someone else. So it asked me to, or prompted me to change the name. We have objects. Objects are the fundamental entities stored in S3. They consist of the data itself, metadata, and a unique identifier, which is the key, within a bucket. An object can be any file such as images, documents, backups, or log files. And then we have the keys. Each object in S3 is identified by an unique key, the file path, within its bucket. Some of the common use cases for S3 include backup and restore, data lakes for big data analytics, static website hosting, media storage for mobile and web applications, and disaster recovery. Basic operations in S3 include uploading objects. Files are uploaded into a bucket. Each object can be up to 5 terabyte in size. Retrieving objects. Objects can be accessed via their unique key using the S3 API, AWS SDKs, or the AWS Management Console. Deleting objects. Objects can be deleted individually or in batches. Next, Let's look at managing permissions and storage classes. Now, S3 offers a flexible permission model allowing you to control who can access your data and how they can interact with it. Permissions can be applied at both the bucket and the object level. Let's look at some bucket policies. Now, the bucket policies define permissions for an entire bucket affecting all objects within the bucket. Policies are written in JSON format and can be used to grant or deny access to specific AWS accounts or public users. Here is an example of a bucket policy where we are doing the effect to allow principal everything. Action is s3.getObject and resource is the bucket that we want. Then we have the access control list or ACLs. ACLs grant specific permission, which is read write, to individual AWS accounts or groups. Example, public access. ACLs are less commonly used than bucket policies but still useful in some cases. Then we have IAM policies. IAM policies can be used to manage permissions for individual users or roles accessing S3. For example, you can allow an EC2 instance to access a specific S3 bucket by attaching an IAM role with the appropriate permissions. Next, let's look at storage classes. S3 offers different storage classes optimized for varying use cases in terms of access, frequency, cost, and durability. First one is the S3 standard, which is designed for general purpose storage of frequently accessed data. It's high availability and low latency. Durability is 99.99%. S3 intelligent tiering automatically moves data to most cost-effective access tier based on access patterns, suitable for data with unpredictable access patterns. Then we have S3 standard or infrequent access, which is S3 standard IA, ideal for data that is less frequently accessed but requires rapid access when needed. Example, backups. Lower cost than S3 standard but with retrieval fees. We have S3 Glacier, low cost storage for long term archiving. Retrieval times can range from minutes to hours. And then we also have S3 Glacier Deep Archive. It's the lowest cost storage class for data archiving. Retrieval times are typically in hours. Let's go over hands-on building a simple S3 based file upload app here. For this exercise, we'll create a simple web-based application to upload files in an S3 bucket. So for these, the steps that we'll follow is we'll set up a S3 bucket, we'll configure the bucket permissions, we'll set up AWS SDK for file upload, and we'll test the application at the end. So let's jump into it. Let's get started. So step one is set up an S3 bucket. For this, what I'm going to go do is go to my S3 dashboard here. So if you have never used this before, it'll probably say create bucket right over here. So I can just go ahead and directly say create bucket. In here, I'm going to say general purpose, and for the bucket name, I'm going to call it my file upload bucket, something like that. Let's see if this name is fine. I don't know, let's see if it works, but we'll know. Next, it says copy setting from existing bucket. I don't have anything, so I'll leave it as it is. Next is ACLs disabled, which is recommended, so I'll keep all that. Block all public access. Make sure that you have block all public access for security reasons here. And then bucket versioning, disable, tags, nothing, leave it as it is. I leave the rest of the stuff, default encryption, everything as it is, and say create bucket. So that will, if my name, of course, Toots is what I'll call it, and create bucket. Hopefully this works, and my bucket is created. Now next step in this particular case was to configure the bucket permissions. So go to your bucket and go to the permissions tab here on the top. Since it's block all public access, I'm going to just remove this for now. It's going to ask me to confirm, and I will add my policy right here. I'm going to say edit, add a new statement, and inside here principal is star, and allow action is s3 put object, that's my permission action that I want, and to resource is this here slash star, and save the changes. So that will complete our second step, which is configure the bucket permission. Now next step is to set up the AWS SDK for file upload. So first I'm going to open my terminal, and in here the first step in setting up AWS SDK is install the AWS SDK. Now it's a web application, so you'll probably use something like Node.js. If you have Node.js installed on your computer, that's good. If not, you can go to Node.js and check it out. There's a bunch of different options, but I'm going to go the Node route. You can check your Node version by saying node-v, which means I have it installed. If you see something else, just go ahead to Node, just Google Node and then install Node. So clear this out, and first thing I'm going to do is install AWS SDK. That's the Amazon SDK. So once I do this, so inside this setup AWS SDK, the step that we have to do is configure the AWS credentials. So for that, what I'm going to do is I'm going to go to my AWS here, and here I will try to get my credentials, because I can't upload it without the credentials, and I've deleted all the credentials from before. So I'm going to go to my account, security credentials, and here I am going to create, I already have an access key, looks like here, so I am going to delete this one first of all, because I don't want that. I'm going to say delete, and create a new access key. New access key, I understand, create access key, and it created this access key, and I will go back to my, I'll go to my terminal and say AWS configure. It will ask me my new key, my secret, this is fine, JSON is fine, clear, perfect. So that should have our step for setting up AWS SDK completed. So now that we have set up the AWS SDK, let's go and do the file upload. So for that, I'm going to open editor and save this on my desktop as, I'll call it upload.js, since it will be a JavaScript file. Constant, first I'm gonna require the AWS SDK, so I'm gonna say that AWS -SDK file. Next thing that I need is the file service which I can upload files, so I am going to say require -fs. This is in Node, lets you do file operations. Next, I want to configure the AWS SDK with region and credentials, so I am going to say aws.config.update, and region that I want to use, region that I want to use is US-East-1. You can always cross check with your object of where it sits in Northern Virginia, which is US-East-1, so that is good. So I'm going to go back to my editor and complete the code. So this will configure your AWS SDK with a particular region. Then I'm going to create a constant s3, create a new instance of that by saying new AWS.s3. that's the function that you create. I need the bucket name, so I'm going to create a bucket name variable, and for this I am going to give the bucket name, which in this case is, this is my bucket name. Next, I want to write a function to upload the file, so that will be, I'll call it upload file, don't make it too complicated, and which takes a parameter of file path, and to that inside here I'll get the file content first from the file path before sending it. So file content equal to fs dot read file sync. So this is the function which is provided by the file system to read a particular file that you have provided, and that file will be converted to bytes, so it is ready to be sent. Next, I need to set up the parameters of my request. In this case, I'll say bucket that I want to upload to is bucket name. Next parameter that I have to give is key, which is, I'll give this, okay, there, this one. Inside that, I'll say uploads slash dollar. I'm going to use the date parameter dot now, and the underscore dollar. So this is the, I'll use the file path just to make this, the reason I'm doing this is to make a unique file name, file path. So that should uploads slash, it will add it in that particular for as a create as a key, and then I'll say body is whatever body I have, which is file content. Perfect. So that completes my parameters. Next thing, s3 dot upload, that is the method that I can call on the upload, the s3 instance which I've created, s3 variable that I've created here, and it needs params, and if there is error or something, that will be given over here. We'll run this and write this here. Perfect. Next thing is if error. So let's say if something went wrong, I want to see what that is. Console.log, I'll say error, I'll print out that error. And next, if everything went fine, I'm going to run the else loop where I'm going to say console.log, and I'll say, I'll give a special character so it can use my variables. Uploaded successfully at the location that will be passed back to me, which is data dot location. That will come back from this data parameter right here. So that's good. Next, let's make sure that everything is closed properly. So this here, and then where is my closing for? Okay, the main file here. I'll move it up so you can see clearly. Close this up, and now let's upload a file. So to upload a file, you call the upload file function, and pass a file to it. Let me see if I have a file. Let's make that ready. So I'll create a new file. I'll just say test file and save it to my desktop, and I'll call it testfile.txt. Okay, that's the file that I'll save, and here I will give the path to that file, which is testfile.txt. Let's make sure testfile.txt, that's the right name. You can test. Okay, perfect. So now we can run this. The next step in our thing is test the application. Now you can upload this to Lambda or create a EC2 web server and then run it from there. But what I want to do is I want to run this from my local. Now let's run node upload.js, and it says file successfully uploaded to this particular. So let's go back and check if it's uploaded to this particular location. I'm going to open this, make sure I am in my uploads folder, and there is upload folders created, and there is my date time with the file path file right over there. I can download this file and see if it's the right one. I can, if you want to check this, I'm going to open that, and if you look at the, once I open the file, you'll probably see it's the same file as the one that we created, which was this one, text file, and if you see, it's uploaded. So that's a successful hands-on project for this. If you had any questions or issues, let me know in the comments and I'll get back to you. Project 3. Create a static website hosted on S3 with custom domain and security settings. In this project, we will host a static website on S3 and configure a custom domain and SSL, which is HTTPS, for security. For step 1, we'll be setting up an S3 bucket for static website hosting. For step 2, we'll point a custom domain to the S3 bucket, and in step 3, we will configure SSL, which is HTTPS. So let's jump into this and start with our project 3. Step 1 is set up an S3 bucket for static website hosting. So for this, what we're going to do is we are going to open our S3. I'm going to click on create bucket, and here I am going to give my name as, let's say, AWS Training Academy.com, which is the URL probably that we'll pick later. If I get US AWS training, I'll use the AWS training, but yep, let's see. And I'll say remove this block called public access. I acknowledge and leave everything as it is and create my bucket. Next, let's go inside this and create permissions. And inside my permissions, I am going to change my bucket policy here, and I will say edit because I want to get I will create a policy where people can access my or read my files. I'm going to say principal star allow. Action is S3 get object. That's what I want to do. And then resource in this particular case is this resource right here. Say slash star. So that should work. I am going to save these changes. That takes care of permissions. Also, we'll go to properties, and at the bottom I will say edit, enable, and host a static website. So this is for static website, and I will create two files, index.html for my main page, a default page of the website, and error page if I want to show an error page. So I'm going to create those two files. I've already created those files. What I'm going to do is I'm going to bring them in. One of them, the index.html, looks like this, where it says this is home page, and I have created error.html file which says this is error page. So I'm going to take both those files and upload it here in my bucket. So both of them look fine, and I'm going to say upload, and I'll upload both those files, and they are available here at this particular place. I'm going to close this out, go to properties again, and at the bottom if I click on this URL here, it should say this is home dot, because that's my index page, and if there is error I can also look at error.html, and this is error page. So both of them are uploaded fine and they are available right now. So the next step now is to point a custom domain to the S3 bucket. I don't have a custom domain, so I'm going to go to route 53, say 53. It will give me an option here to create a register a domain. So why not just go ahead and register a domain? So it has options to registering a domain or transfer existing domains. So I'm going to create a new domain for this particular training. I'll try to see if AWS training is available, which probably is not available, of course, but it has AWS Training Center available, AWS Training Academy. So I'm going to use, I think, AWS Training Academy.com. I'm going to select this, and it says it's $14. I'll say proceed to checkout. Auto renew is turned for one domain, which is this one. I'm going to turn it off because I don't need this domain. I'm just doing it for the training purposes, so I don't care about it. And I'm going to press next. It asks me for my contact information, so I'll fill this up and forward this up. So once I fill out the entire contact form, I am going to say next. AWS training, it's all good, contact information is there, terms and I have read, and submit. Look at check status here, and the check status is saying that it operation ID in progress, so I'll have to wait for a little while. I'll wait for it and then I'll come back in a few minutes. So I got an email saying that my domain name is available, so I can go to now the hosted zone, and you'll see our URL is available along with a hosted zone. So I'm going to click on this hosted zone, and here I'm going to create a record. I'll say it's an alias, and the endpoint is alias to S3 website endpoint. Choose the region to US-East, the same that where we hosted the endpoint, and it will automatically show me this S3 endpoint that I've created. I'm going to set that, and I'll say create records. So this should be good. It's going to take a few, as it says, it's going to take a little bit time to show to point kind of create this record, and so we'll wait for a few seconds and then we'll open the website in a new tab. So our website is this one. I'm going to copy it and keep it ready. And there you go. As soon as I say awstrainingacademy.com, it opens up the website, and I can say /error.html and it show me the error page right here. So that kind of completes our step to point a custom domain to S3 bucket. Now it says next step is configure SSL HTTPS using AWS Certificate Manager. If I go back to the website, something that you'll figure out or realize is it's not, it says on the top not secure. So if I say https:// it will not work because we have to create something called as the SSL HTTPS using the certificate manager. So let's jump into step number 3. I'm going to go to my AWS Management Console, and here I am going to go to the certificate manager, which is this one here, and here I have this option to request a certificate. So I'm going to say request a certificate. I'm going to say request a public certificate, request a public SSL TLS certificate from Amazon. That's what we need. So I'm going to say next. DNS validation or email validation. Since I have the access to modify the DNS configuration, I'm going to select DNS validation. If you don't, you can always use the email validation. I'll keep the rest of the stuff as it is, and I'll say request. Now next, it's asking me the domain name. My domain name was AWS. That's AWS Training Academy. So I'm going to take that and enter it here. Okay, perfect. DNS validation, everything looks good. I'll say request, and now it will say certificate request where the status of pending validation has been created. Further action is needed. So next, what I'm going to do is I'm going to look at what this validation is. So inside this, now I can go here, and if you see pending validation, and this is asking me create records in Route 53. So I'm going to do that. I'm going to click on this, and for this particular thing, I'll say create records, and say successfully created DNS records in Amazon Route 53 for certificate. Perfect. So that has been created. I'll go back to certificates again. Let's see, it says pending validation, so we'll wait for it, and it says status is issued, success. So it worked perfectly fine. So we have the certificate created and validated. So next step is to set up the CloudFront for HTTPS. So for this, you have to go to CloudFront, which is AWS Content Delivery Network Service, and create a distribution. So I'm going to go to CloudFront and create a CloudFront distribution, and it says choose the AWS origin to enter your origin domain name, and that is this one. It will automatically show up. Next, the origin path, which is optional, so I'm going to leave that as is. Name I'll leave as it is, public, and add header. I don't have to do anything else. Pattern default HTTP and HTTPS. Get head. Caching optimized, looks fine. So for this, I will select do not enable. That's fine. Create distribution. So that is created. Now I am going to close all these things. So once my distribution is completed or enabled, I'm going to go here and do one more change, which is go to edit, and here alternate domain name, I am going to give my awstrainingacademy.com as the alternate domain name. Save changes. Next, I'm going to go to Route 53, and inside my hosted zones, this zone, I'm going to create a record, say alias, select the CloudFront distribution, and choose this one that I've created, the certificate, and say create records. Name already exists, so this one, or we already have that. So what we are going to do is, since we had created to point to S3 this one, Now we don't need that because my CloudFront is pointing to S3. So I'm going to change this one to CloudFront, and destination is this one this time, and save. So that should be saved. Now we have that. Now we can go to the website. Let's go back to our awstrainingacademy.com, and that's our error page. Let's go to index.html, and we have the index.html. So now we have the HTTPS working too. So this kind of wraps up our entire project, where we did set up a S3 bucket for static website. We did point custom domain to the S3 bucket, and we finally configured SSL, and that was working. So if you have any questions or had any issues while following along, let me know in the comments and I'll get back to you. Thank you. Amazon RDS, managed databases. In this particular section, we are going to look at overview of RDS and supported database engines. We cover creating and managing RDS instances, and then we're going to jump into a hands-on exercise for connecting an RDS database to an application. And finally, we'll do our project 4, which is build a blog application using EC2, RDS using MySQL, and S3 for image storage. So let's get started. First, let's go over the overview of RDS and supported database engines. Amazon RDS, or Relational Database Service, is a fully managed database service that makes it easy to set up, operate, and scale relational databases in the cloud. RDS automates time-consuming tasks such as hardware provisioning, database setup, patching, and backups, allowing you to focus on your application. Some of the key features of Amazon RDS include managed service. AWS manages routine tasks such as backups, software patching, monitoring, and scaling. Automated backups. RDS allows you to enable automatic backups as well as create manual snapshots of your database. Multi-AZ deployments. RDS supports automatic failover to a standby instance in a different availability zone, improving database availability. Read replicas. RDS allows you to create read replicas for performance and scalability. Some of the supporting database engines include Amazon Aurora, MySQL and PostgreSQL compatible, offers high performance and availability than standard MySQL PostgreSQL with up to 5 times better throughput. We have MySQL, one of the most popular open source relational database. We have PostgreSQL, an advanced open source relational database system known for its extensibility and SQL compliance. MariaDB, a popular open source database created by the developers of MySQL. Oracle, enterprise level database system with support for various versions and editions. Microsoft SQL Server, Microsoft's relational database widely used in enterprise settings. Let's look at creating and managing RDS instances. The steps for that is, first you have to launch an RDS instance. For that, go to the RDS dashboard in the AWS Management Console and search for RDS and navigate to the dashboard. We're going to run through this in the hands-on, but I'm going to put the steps down here. Next, click Create Database. This begins the process of launching an RDS instance. Next, select the database engine. Choose the database engine that best fits your application needs. We will be using MySQL, so that's what we will be selecting. Next, choose a database template. Choose the appropriate use case for your database. For production, automatically includes features like multi-AZ and backups. For dev and test, simplified for non-production environments like single AZ. Specify database settings. In this case, we'll be specifying DB instance identifier, a unique name for your RDS instance. We'll give a master username, the admin user that will have full control of the database, and we'll give the master password. And for that, make sure you choose a strong password. Configure instance size. Choose the appropriate instance type based on your needs. For small scale applications, the db.t2.micro instance type is a good starting point, and it's eligible for free tiers, so we're going to try that. And then storage configuration. Set the storage size for your database. For most cases, 20 GB general purpose SSD is enough. for small applications. You can enable storage auto scaling if you expect future growth, and then enable multi-AZ deployment, which is optional. For production environments, you may want to enable multi-AZ for automatic failover to a secondary availability zone. This ensures higher availability in the case of failures. We are not going to do that in our sample because we're just going to create something for learning purposes. So single AZ works for us. Set up connectivity. We'll have to set up the virtual private cloud VPC. Select the VPC where the RDS instance will be deployed. Next is subnet group, which automatically is selected based on the VPC configuration. And then public access. If you want your database to be accessible from the internet, select yes. However, for security reasons, databases are often placed in private subnets without public access. Next, security group. Choose an existing security group or create a new one that allows traffic to the default MySQL port, since we're using MySQL 3306. Backup settings. Enable automatic backups specifying the retention period, example around 7 days. Enable enhanced monitoring for deeper insights into instance performance metrics. And finally, launch the instance. Review your configuration and click create database in this particular step. Now, step 2, managing your RDS instance. First thing that is important is monitoring and metrics. In the RDS dashboard, you can monitor your instance's health, CPU usage, memory, IOPS, and more. And you can also use CloudWatch to set alarms and get notified if thresholds are exceeded. And we're going to learn about CloudWatch later in one of the videos. Backup and restore. RDS automatically backs up your database daily. You can also create manual database snapshots at any time. Restore a database to any point within your retention period by selecting Restore to point in time. Now, scaling. RDS allows you to scale vertically by changing the instance class, example from db.t2.micro to db.m5.large, which adds more CPU and memory. You can also scale your storage capacity without downtime if you enable storage auto scaling. Security. RDS integrates with IAM to control which AWS users and services have access to the database. For enhanced security, use SSL TLS encryption to encrypt data in the transit. So these are the two steps that we'll be doing in our hands-on. So let's jump into the hands-on exercise where we will be connecting an RDS database to an application. In this hands-on section, we will connect, as I mentioned, RDS database or MySQL instance to a web application running on EC2 instance. So there'll be a bunch of steps. The first step will be launch a MySQL RDS instance. We'll follow all the steps that we just went over. Step 2 is launch an EC2 instance from the application. And step 3 is install MySQL client on the EC2 instance. And finally, create a simple web application to access this database. We'll do that. We'll use PHP for our code to connect to it and get the database data. So let's jump into it. Step 1, launch a MySQL RDS instance. So let's go to our management console, and here let's search for RDS. Once you're in the RDS dashboard, scroll down and you can create a database from right here. Inside here, I'm going to say standard create. I'll select MySQL. I will leave everything else as it is here. For templates, there is production, which will use multiple AZs, or you can use dev test. Or for this particular example, I'm going to just say free tier because I can play around without paying anything. Next, availability and durability. So if I select the dev test, you can actually select these different things. But since I am using free tier, and it doesn't matter because it's about how many what deployment you need. You want to have multiple instances of your database in different zones, then you probably select this. But for us, we'll just go with this. I am going to give a name to this. I am going to say AWS Training DB. Credentials, I'll leave it as master username is admin. Remember this for future use. And then at the bottom, we have password, which I'm going to also use as admin. It says very weak, so I will give a strong password. Okay, that kind of works. Next, confirm. So next step is instance configuration. For this, I'm going to go look at the options And if you see, I have these two options that are available under the free tier, so I'm going to leave it as it is. Next, let's look at storage, and it's saying general purpose SSD 20. That looks good. Next thing, connectivity. Don't connect to an EC2 compute or connect to an EC2 compute resource. I'm going to leave it to default. Don't connect to an EC2 instance. Default VPC, that's fine. After the database is created, you can't change, that's fine. And subnet group, I'll leave it to default. Public access, I want to access this, so I'll probably select yes for now, because however, for security reasons, databases are often placed in private subnets without public access. So I'm gonna select it as yes for now because we're gonna directly access it. And for VPC security group, it's saying choose existing, but we have the default one, so I'm gonna just leave that as the option. Availability zone, no preference. We have different options here. I can always select 1A, yeah, just so that I know which one I'm connecting to. I'm going to leave the RDX proxy, I don't need that, so I'm going to leave everything else. There's also an enable enhanced monitoring, which I don't need. Database instance, this is what it will cost me. Storage and total around this much per month, that's what they're estimating. And I am going to go ahead and jump into create database. It's going to give me some suggested add-ons for AWS. These are database. I am going to say nope, I don't need that anymore. So since I'm still working on it, what I'm going to do is I'm going to go to step 2, because that's all that you need to do to create a database. And step 2 says launch an EC2 instance for the application. So I'm going to go, you have idea of how to create an EC2 instance. So I'm going to directly jump into EC2. I'll have to connect it through SSH, so I have deleted pretty much everything from before, so I'll have to do it from scratch. So I'm going to say launch instance, fastest way. My DB tester, and I'll select this. I'll keep the free tier one. Everything looks fine. T2 micro key pair, I'll have to create a new one, so I'll say create new key pair. I'm going to call it my DB testing key and create the key pair. I'll make sure I have it on my desktop. Next, let's see, create security group, allow SSH traffic. I also need traffic from outbound traffic on port 3306 for MySQL, so I'm going to go and set it up after this. Configuration, everything else looks fine, and I'll say launch instance. Once I'm done with that, I'm going to go back to my instance, and as I mentioned, inside my security group that I just created, which is this one, I am going to edit the outbound rules. I'm going to add a rule here, and for this one I need the 3306, which is MySQL port, so I'm going to open this. It will give me the 3306 port. Save, and oh yeah, I also have to enter this and say save rules. Next, I need to SSH into it, into this particular EC2 instance. So let's jump into the instances, and here is my instance running. So to connect to this, I can click on this here and then open my terminal, increase the size, desktop, ls, and I have my key already over there. So the first step is this. Okay, next step is SSH into it. It will ask me to add the fingerprint, yes, and I am inside the EC2 instance. Let's go to the next step. Install MySQL client on EC2 instance. So that's our next step. So in this particular case, first let's go to the SSH that we opened. So I'm going to say sudo yum install MySQL community client. Say yes, 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 and it will install the MySQL client here. So next step is to connect to the RDS MySQL instance using the MySQL command. So just clear this out. So I'll say MySQL dash H, the RDS endpoint. So we'll have to go and get that RDS endpoint here. So we'll open our RDS. Let's see if it is available. And we have it's available, so it's completed. Let's go here, and the endpoint is right here. So I'm going to copy this endpoint, paste it here. Next, I need dash U and our master username, which is admin dash P. It will ask me for the password, and I'll enter the password now. So it connects directly, and I have my MySQL prompt. So that kind of completes our installing MySQL client on EC2 instance. Next, we'll look at how to create a simple web application to access the database. I'll go back to my dashboard here, and here I am gonna say EC2, and I think I already have the connection. So let me exit this, and here the first step will probably to install the necessary components. Example, we'll probably have to create a PHP Apache Node.js on the EC2 instance. So what we'll do is sudo yum install Apache. We have PHP MySQL ND, and say yes to all the prompts. And it's complete, so that's good. Next step is I'll start my Apache server, systemctl start httpd, and I'll enable it. Sudo systemctl enable httpd. So that will make sure that it's there. Now next thing, we have to create a PHP file that connects to the MySQL RDS instance. So what I'm going to do is I am going to create an index.php file and then upload it to the HTML folder. So I'm going to say cd. I will probably have to go to that particular folder. So slash variables slash w slash html here, and here I will, and in this particular folder I will create the file. I'll call it index.php, and my index.php is created. I am going to write this file. It's not letting me write because I think I don't have access. So I'm going to go back and say chmod. So that is not permitted. It says chmod dot 777 dot, and that will take care of it. Next, I will go ahead and write this file, make sure I can write it. So I'm gonna try to see that's written. Perfect. So here for the PHP, I will write some PHP as insert, okay, question mark PHP, and I'll first give the server name variable, which is my the RDS endpoint. So I'm going to go to my RDS again, get that endpoint, databases, click on this. This is the endpoint. I copied it, I'll paste it here. Perfect. Next thing, I need my username. This username is admin. Next, I need my password, and password is AWS training 1982. Next thing that I need is the database name. I think we named it AWS training database, if I'm not wrong. Yes, it is. Next, I need to create a connection to this particular MySQL. So I'm going to create a connection variable, and the code is MySQL I, if I'm not wrong, and I have to pass server name, I have to pass username, I have to pass the password, and I have to pass the database name. So that will create a connection to my MySQL server. Now let's check the connection. If $connection has a connect error, then in this case I will say die. I'll kill the connection, say die, connection failed. Probably want to give the description of it, $connection connect error. Okay, so that's all good. Okay, so that's the first case. Now if everything was successful, I am going to say echo connected successfully. Now if this thing, if there's a connection error, it will just stop everything here and not go to this code here. So just to let you know. Okay, so that takes care of it. I'm going to save it, and that file is saved. Now what we have to do is, this file is saved as index.php. I have to access it via the browser using the public IP address of this EC2 instance. So I'm going to go ahead and go to EC2. I have one instance is running. Click on that. This is the public IP address. I'll open this address. Don't have HTTPS. Open this, and here I am going to say index.php. Enter, and it is not working. So something's wrong with our script. Let's look here. Vi index.php. Database name. Let's check the database name. RDS databases. Click on the database. I feel, oh yep, we have not given a database name. So let's go back here, update this to say no database name. See, that's it. Let's come back, refresh, and connect it successfully. So there we go. We were able to go through the entire steps of launching a MySQL RDS instance, launching an EC2 instance for the application, install MySQL client on EC2 instance, and create a simple web application to access the database. So that kind of covers our hands-on. So if you have any questions, let me know in the comments. If you were not able to follow along or any issues you faced, let me know in the comments and I'll get back to you. Project 4. Build a blog application using EC2, RDS, MySQL, and S3 for image storage. In this project, we'll build a simple blog application that stores blog posts in an RDS MySQL database, uses S3 for image storage, and runs the application on an EC2 instance. So it's a little bit more complicated than what we did on hands-on. So step 1 will be set up RDS MySQL for blog post storage. Then we'll set up an S3 bucket for image storage. Then we're going to launch an EC2 instance and deploy the application. And finally, we'll create the blog application. So let's jump into it and create our project 4. Step 1, set up RDS MySQL for blog post storage. So in this case, we're going to create a MySQL RDS instance as we've done in the previous section, but we'll start from scratch and we'll create a database for our blog post. We'll log into the MySQL RDS instance and create a table to store blog post data. So let's start with RDS. I'm going to click on RDS, go to databases, and I'm going to create a database here. This is standard create. I'll use MySQL. I will say MySQL Community Edition, uh, and in here this is good. I'll again use the free tier one. I am going to setting database instant identifier, that's fine. Admin, self-managed. Password, I will give the same thing again, AWS training 123, AWS training 123. Perfect. So that's good. Show. Let's see anything else that we need to change here. Everything looks good. Use default VPC. Have this set up. Availability based zone, no preference. Oh, actually, I'll say US1 East. Everything else looks perfect, and I'll say create database. So this will start my database process. While it's still creating this database, what I'm going to do is I'm going to go and create the S3 bucket. So I'm going to go inside S3 and create a new bucket, general purpose, and this bucket I will call it, let's say, my blog images BKT. So this is where all the images from the blog will be saved. Object ownership, ACL disabled. Block public access settings for this bucket, I'll enable it so I can add data from my application. Bucket versioning, disable. Tags, server-side encryption, bucket key, and let's look at advanced settings if you have anything in here. Object lock, nope. So create bucket. So let's go ahead and create our EC2. I'm going to go to EC2, and here I'm going to launch a new instance. I'm going to call it my blog server AWS. I will use the basic ones, everything basic. Select key pair. I'm going to use the MyDB testing key which I've created in the hands-on video. I'm not going to create a new key, but you can create if you want to. And everything else looks fine. And I'm going to say, actually, I'll say allow HTTPS traffic, not HTTPS, allow HTTP traffic from the internet. It's good, and launch instance. Now this is successfully launched. Now let's go ahead and connect to this via SSH. So I'm going to go here. I'm going to select the instance and connect to it using this. I'm going to open a terminal. That's cd desktop because that's where my key is. Make sure, I think I had already done that, so I don't have to do that, but I can directly connect to SSH. Yes, and it's connected, clear. So I am in my EC2 instance. Now go ahead and let's go ahead and install whatever we need, like sudo yum install httpd php dash mysql nd dash y, yes to everything, and it's going to install those packages. Perfect, and that's done. Let's start the server. Sudo systemctl start httpd, and next enable it. Sudo systemctl enable httpd. That's done. Let's clear it out. So until now we have pretty much set up this blog post storage. We created the S3, and next this is the S3 bucket. We created the database. We launched an EC2 instance and deployed the application. I mean, didn't deploy the application. We'll deploy the application, and then finally we'll start with creating the blog application. So let's go ahead. But before going here, let's check the status of our database. Can go to RDS back again, click on the databases, and it's available. So the database is available. One of the things that we did before was making sure that the security group that is created, let's go inside here and then look at the rules, and we have to go to outbound rules, edit, and in here add a rule that was that was saying that we need to make sure that traffic to MySQL, let's go ahead and say MySQL 3306 is enabled. Save rules. Next step, let's go ahead and create that PHP code for the blog creation. I'm going to go ahead in my S2, the EC2 instance, which we have SSH2, and go to cd/variable/ www/html. Inside here, I'm going to create that. So let's see if I can create. But before that, sudo chmod 777 dot. So I have full access, and I'll say vi index, or I can call it something else. I'll call it blog dot php, something like that. And here, let's start inserting stuff. So PHP, so I'm gonna say this, closing PHP tags, and in here I will use the AWS SDK for PHP, which is require vendor slash auto upload, auto load, actually not auto upload, auto load dot php. And then I want to use AWS slash S3 slash S3 client, so I'm gonna add that. And to access that, let's create a variable S3 equal to new S3 client. That's how you do this. And inside here I will give options like version and region that I'm using. So I am going to say version is equal to, let's see if I have all the version is, it's always a good practice to move it in different lines so it's cleaner. So I have the version that I'm going to use is the latest version, so you can just say latest. And then another thing that I mentioned was about the region. So region that I want to deploy this, or where this application is deployed, is US-East-1. So specify that. Now next we need to give that server names. So server name equal to whatever the server name RDS endpoint is. Next I'll give the username, which we know is admin, so I can just specify now. And we know the password that we're using, that is AWS training 123. And then finally the database name, I think it's nothing, so I will leave it empty. Next time probably I'll use a blog or something. Let's see if I can go and edit it. So I can go to RDS, and inside the database have this database here. Let's get the endpoint, and I can add that here. And then we'll create a connection to that MySQL. So that is dollar connection equal to new MySQL I, and we pass dollar server name, dollar username, dollar password, and dollar DB name. That's all we need to do to create the connection. And once the connection is started here, I can check if dollar underscore server is request underscore method. So if there was a request to post, a post method was sent from the, let's say, web server or web, the client user has sent that. So in that case I am going to get that request. So the user needs to send me a title, and that I can fetch by saying this is the title. Next I need them to send, let's say, some content of the blog. Content equal to dollar underscore post, that will also be in the post data content. Next, I want to get that image, so I'm going to say $file, the file to upload, the image to upload. So that I will say equal to dollar underscore, and it comes with files parameter, and inside that image there will be a temporary name. That's how the file will be fetched, and then I'll need a key which is base name. So we'll set the name as dollar underscore files, whatever the image is, and its name that is coming from there. Wrong quotes. Name that we get, that's what we'll set as the key for it. Next, bucket, where I want to upload this. The bucket is, let's go to S3 and search for buckets. Okay, there's the bucket. That's the name of my bucket, which I'll specify here. So that's the bucket that I want to save it to. Now I'll try and put it in there. So first thing how to do is write a try catch here if there's error or something. So that's why I'm doing a try, and I'm seeing result of this operation, which is dollar. I think we created this S3 parameter on the top here, right here, S3, where we created to the client. So I am going to go there to that S3. I'm going to say put an object, put object, and that object is, put in bracket, it needs a bucket, or it needs a bucket parameter, and that we already created, which was under the name dollar bucket. Next, it needs a key. That's why we created that key parameter, and we'll pass dollar key to it. Next, it needs the source file, and that is coming from the dollar file that we created above here. And next, finally, it needs the ACL, which in this case is public read. So this image could be publicly read. That's the property that I'm setting to this. And then I have not closed it. Let's make sure I go all the way to the end, public read, and then I'll close this square bracket and the angle bracket, the curly bracket, not curly but the actual bracket, and then I'll set the image URL equal to dollar result. So once it's uploaded, it's going to give me back that inside result, which will have the key object URL. So that's how you get that. But what if there is an error? So I'm going to catch this exception $e, because I want to print it out, and I will echo this back to whoever made this request. Call it upload error and $e to get message. So whatever that error was, we are trying to print that out here, and that's what's happening here. Now I also need to insert this into, once we have that image uploaded, we want to make a SQL query. So I'm going to say SQL equal to insert into, the name of the table is, we didn't create it yet, but I'll call it posts. It needs title, content, and image URL. These are the three things that we probably saw that we might need, and the values of these will coming from above, which is, since it's a string, I'll say dollar title. Next is dollar, again this is also a string, so I'm going to say content, comma. The third part is image URL, which is what we just fetched, which is also a string. Dollar image, what was it? Image URL. There you go, image URL. So I have that. I'll close my bracket. I'll close my this bracket here and semicolon. Perfect. So this is my this will create my SQL query. Now let's try it. If dollar connection, is that the name that I used? $CONN. So $CONN query. So I'm asking to that query that to that connection, can you run this SQL query? If you can run this SQL query, is it true? Then, which means it was successful, and I can say echo new post created successfully. But if it didn't go through, if it didn't go through, yes, I was right over there, I think, else I'll say echo error dot dollar. In this case, SQL, whatever that query that I wrote, I want to display it before I tell what error it is. So sometimes it's good to see the SQL query so you know what the problem is. Connection dash error. This will give me the actual error, and that it will tell you this SQL query had this error. So that's what this will show you. So this is all that I need to do here. This is an example of how you can insert into it. As we are not going to do the entire blog application, but just to get an idea, we'll create this. Let's create also a, let's say, HTML file. I'll call it home.html. Inside this, we'll just make a simple form. I am going to say form, and inside this form there is an action equal to what was my PHP file that I just made? Let me just WQ. It was blog.php. So let's say this will be sent to blog.php, and inside here we'll do a method of, so now we are doing the UI code for what the user will see. Post method enc type encryption type equal to, in this particular it's a multi-part form, so I'll say multi-part slash form data. That's what we will send in this particular case. Next, we need to provide the get the title from the user, and that is a normal input type equal to text, and name equal to, what was the name that I used? I think title. So I'll use that same name here, so when it sends the form, I don't have to do much, and I'm not going to do styling and stuff. If you are free to do whatever you want, but I'm just going to create a basic form here. Text area name equal to, I'll say content, because that's what we are sending, and close that text area, and I'll do the next line here. It will be really bad looking form, but it will work. That's what we want. Input type equal to, so it's a file upload, so I'm going to say file name equal to, also I'm not going to do any validation. I'll hope like the user will enter everything in this case, but you're free to add your validation. Finally, input type, in this particular case I'm going to use a submit button by saying submit value equal to create post. That's pretty much, let's close this and let's close the form. So this looks like a very simple form. It's created, that's done. Now next thing is, we have to still create the table. So we have the database, RDS database created here, but to add tables to it or add a database into it, if you see inside my configuration, I have database name is nothing. So I am going to go into my here and do a MySQL connect to that particular. Oh, let's clear it first. We don't need all these things. I am going to go to the root, clear again, and now I will connect to the MySQL server. So I'll say MySQL minus h, if we did this in the previous section. So we are going to do the same thing, get the RDS databases address or endpoint, which is in the first set here, endpoint, and then I'll say user is admin, needs a password. Oh, I think I forgot to set up the MySQL here, so I'm going to run that. Sudo, so sudo yum install -y. It says already installed. I've installed it before, but if you have not, just give this command and it should work. And then I'll say MySQL. I'll give that command, which was, let's see, MySQL -h database admin p, and it says enter the password, which is AWS training 123, and I am inside my MySQL prompt. Once I'm here, I can say create database. Let's give it a name, blog, and then I'll say use blog. So now I've changed the database to this blog, and I'm going to say create table, call the name table post, and inside this I'll give different parameters, like for example ID integer, which is auto increment primary key, make it the primary key. Next I'll create the title, which is varchar 255 not null. Next I will create the content, which is text not null. So I'm pretty much saying everything is required. And then finally I need the image URL, image underscore URL, which is varchar 255. This is just a string, that's why saying that not null. And then created at the image URL is a string to a S3 buckets URL. Timestamp default to current timestamp. Close this out, and my table is created. So now I can exit out of this, clear, and let's go to the var www/html vi, and the file was blog.php. This was it, just cross checking everything here based on the name, content, image. Okay, everything looks fine. The only thing that I probably want to change here is the database name, since I've created the database blog, blog wq. Okay, that's perfect. So that's kind of creates our entire structure where we have done everything. Now we can probably go ahead and test it. So let's close this, and actually I'll keep it open. I'm going to go back here, and let's go to the S3, EC2 bucket, and our instances, and this is our blog. I am going to open this and open it in a new browser here. It will say it works, but I need that form that I've created, which was blog, not blog, it was home.html, and there you go. I mentioned it's ugly looking form. My first blog post, here is the content, choose file. I have a test image here that I've created. I'm going to use this, and I'll say create post. It says new post created successfully. Perfectly. Now to test it out, I can go to my S3 bucket to see if the image exists. Go to this blog, and I have this test image here. If I look at it, if I download it, it's the same image that I've created. So perfect. So that worked. Next thing is, let's look at the database, if it's in the database. So I'm going to give that command again to open MySQL, which was this one, password AWS training 123, and I'm there, and I'm going to say use blog, that's my database, and I'll say select star from post, that's my table, and I'll see one blog here with its title, data, and all the stuff here. I can create one more just for the fun of it. Second post, here is the content. I'll choose the same image, no problem. Create post, successfully completed. I can go back to my here, and I'll see two different items here, and probably this is a new image. I mean, same image posted again, but in the same place. So that kind of completes our entire project 4. If you had any issues or any problems following along, or had any issues, let me know in the comments, and I'll get back to you. Thank you. AWS billing and cost management. In this particular video, we are going to go over understanding AWS pricing and free tier services, monitoring AWS usage and cost, best practices for managing AWS budgets. Hands-on will be setting up budget alerts to track AWS costs. And your final project, project 5, for the beginner section, will be create a dashboard using AWS Cost Explorer to monitor your cloud spending. The reason we have put this section in the last part of our beginner exercise is we'll be doing a lot of things, or we have done a lot of things where we probably are initializing something or other, or some resources which might cost some money. So it's good to learn this earlier in this stage, so you do not end up spending a lot of money while you are learning this course. So first, let's go over understanding AWS pricing and free tier services. AWS offers a flexible pricing model that allows you to pay for what you use, with options to optimize costs depending on your needs. Here's a breakdown of the key pricing models and how to take advantage of the free tier services. In the AWS pricing models, we have first one, which is pay as you go. This is the most common pricing model, where you pay for the compute, storage, or other services based on actual usage. There is no upfront cost or long-term contract. You are billed based on hourly or per second rates for certain services like EC2. Reserved instances. AWS offers reserved instances, or RIs, for services like EC2 and RDS, where you can reserve capacity for 1 or 3 years in exchange for lower rates. This option is best for workloads with predictable steady state usage. We have spot instances. Spot instances allow you to bid on unused EC2 capacity at a significantly lower cost than on demand instances. However, these instances can be terminated if AWS needs the capacity back, making them ideal for fault tolerant applications. Savings plan. Savings plan provide a flexible pricing model that offers savings over on-demand rates in exchange for a commitment to a consistent usage amount measured in dollars per hour for a 1 to 3 year term. We have the AWS free tier. AWS offers a free tier to help new customers get started without incurring charges. It includes EC2 750 hours per month of T2 micro or T3 micro instances depending on the region. Then we have S3, where you can use 5 GB of standard storage. You have RDS of 750 hours per month of db.t2.micro in the free tier, and you have Lambda 1 million free requests per month. The free tier service are available for 12 months, after which standard rates apply. Now, we've been using this free tier throughout this course, and that's what we'll be using, and that's why you probably will not see any charges on your credit card if you have created an account along with me, because we have not done much. And every time I create something, after the video is recorded, I clean it out, I delete all those instances and make sure that nothing is running in the background. Now, let's look at monitoring AWS usage and cost. AWS provides several tools to monitor and analyze your usage and costs in real time. These tools allow you to manage your cloud spending effectively and avoid unexpected charges. So, there's AWS billing dashboard. The AWS billing dashboard provides a summary of your current charges, estimated monthly cost, and usage patterns. You can also view detailed billing information for specific services and compare cost over time. We have then AWS Cost Explorer. Now, AWS Cost Explorer is a powerful tool for visualizing your AWS cost and usage. It allows you to analyze spending patterns and trends over time, filter and group data by various dimensions such as services, regions, linked accounts, and tags, and create custom reports to drill down into specific cost drivers. Example, EC2 usage by instance type. Next, we have AWS budgets. AWS budgets allow you to create custom budgets for your AWS spending. You can set up costs and usage thresholds and receive notifications when your spending approaches or exceeds the predefined limits. Next, we have AWS Trusted Advisor. The Trusted Advisor helps you optimize your AWS infrastructure by providing recommendations on cost savings, security, performance, and fault tolerance. It offers cost saving tips such as right sizing EC2 instances or eliminating underused resources. And finally, we have the AWS CloudWatch. CloudWatch provides monitoring and operational data in the form of metrics, logs, and alarms. You can monitor cost related metrics such as EC2 instance hours or S3 storage size to keep track of high usage resources. Best practices for managing AWS budgets. Effectively managing AWS costs requires planning, monitoring, and optimization. Here are some of the best practices to help you stay within your budget. First, set budgets and alerts. Use AWS budgets to create a monthly or quarterly budget for your cloud expenses. Set alerts to notify you when you are approaching the budget limit. Enable consolidated billing. If you have multiple AWS accounts, use consolidated billing to centralize your billing information. This allows you to share reserved instances across accounts and take advantage of volume discounts. Tag resources for cost allocation. Implement a tagging strategy to label AWS resources by project, team, or cost center. This helps track spending on a granular level and makes it easier to allocate costs across departments or projects. Monitor idle resources. Regularly review your AWS resources for underutilized or idle instances, volumes, or databases. Terminate, stop, or downsize instances that are no longer in use. Use AWS Trusted Advisor to identify idle resources and optimize costs. Use reserved instances or savings plan. For workloads with predictable usage, consider using reserved instances or savings plan to reduce costs. Leverage spot instances. For flexible workloads, use spot instances to lower the cost of compute resources significantly. Optimize storage cost. Choose the appropriate S3 storage class, example S3 Standard, S3 Glacier, based on data access patterns to minimize cost. Implement lifecycle policies to automatically transition data to lower cost storage classes over time. And finally, enable cost anomaly detection. AWS provides cost anomaly detection to automatically monitor your AWS usage for unexpected spending patterns and anomalies. Let's jump into hands-on exercise on setting up a budget alert to track AWS costs. In this particular exercise, we're going to do step one, which is access the AWS budgets dashboard. We're going to create a new budget. We're going to set alerts. We're going to review and create an AWS budget. Step 1. Access the AWS budgets dashboard. Now, when your AWS Managed Console, so I'm going to open that, you'll probably go to Billing and Cost Management. And inside that, on the left side, look for budgets, click on budgets. And here, we'll create a new budget. Here, I'm going to use a template. I'll say simplified template. Zero spend budget, which is create a budget that notifies you once you spend exceeds 0.01, which is above the AWS free tier limits. You can also set a monthly budget or daily savings budget, and you can specify that, but I'll call it my zero spend budget. email recipients. Here you can provide emails. So I'm going to say email me, and you can give, as it says, maximum number of email recipients is 10, and then I'll say create budget. Once my budget is set, it's saying if budget is $1 and if there's anything, any notifications, it will send it to my email. So we have completed access the AWS budgets dashboard. We've created a new budget. We've set alerts to receive in the email, and we reviewed and created our final budget. Project 5. Create a dashboard using AWS Cost Explorer to monitor your cloud spending. In this particular project, you will create a dashboard in AWS Cost Explorer to track your cloud spending by service, region, and usage type. The dashboard will help you identify areas where you can optimize your spending. The steps that will follow is step 1 is access AWS Cost Explorer, enable Cost Explorer, then create a custom report. Next, we are going to save the report, create a dashboard, and analyze your cost. So let's jump into project 5. Step 1, access AWS Cost Explorer. Now Cost Explorer is at the same place where we did the billing and billing dashboard. So I'm going to go inside here. On the left side, you'll see the option for Cost Explorer, and you'll see your Cost Explorer here with all the options. It will show you how to create a new cost and usage report, and you can select date range on the right side. So I can here manually select, or I can auto select based on like last 1 day, past 7 days, month to date, 1 month, 3 months. Also I can do future, 1 month, 3 months, 12 months. So let's say if I select something based on my previous like 1 month from August to September end, and then say apply. Actually not apply it, but leave it as it is right now. So we can look at other stuff like granularity. I can say hourly, daily, monthly. I can say dimensions by service. You can select service, you can select region, instance type. So I'll keep it service, and inside my services also you have a different filter saying that you want to, for service, you have a filter by a particular service. You can select that. You can use region. I can say that I want to do by, let's say, US East, because that's where most of my stuff is hosted. Next, I can select based on instance type. For example, if you're using EC2, you want to do T2 micro, or this was for database, so you can select instance types and kind of filter by that. Usage type group, resources, cost category, tags, charge type. So you can select all these different filters for your particular report. So that kind of takes care of our exploring Cost Explorer. We also enable the Cost Explorer, which we're going to do right now, create a custom report and save the report. So let's go ahead, and whatever report we created, I am going to say save to reports library. I'm going to give it a name, my first report, and say save report. So that's saved to my report library. As you can see here, this is my first report, and it will show you this particular report here. So once we completed our report, the next steps is to create a dashboard and analyze your cost. So for that, you can go to data exports at the bottom, and here you can create dashboard. So I'm going to say create a dashboard. I'm going to say standard data report. I don't want to use QuickSight, because for that you'll have to create an account with QuickSight. You can check it out. Also there's legacy CUR report, which is cost and usage report, which you can create, but I'm going to use the standard data export. I'm going to call it my cost, or my valid characters are A to Z. So these are the valid characters. So I'm going to say my cost report first dashboard. I'm going to say CUR 2.0. You have options like cost optimization recommendations, focus 1.2, and AWS. So these are different options. I'm going to create an export of the AWS cost and usage report table. That's all I need for this. I can say include the resource ID, split cost allocation data. I can add those. Time granularity, hourly, daily, monthly. So you can specify that. I'm going to select hourly for now. SQL statement, select the columns you want to be included in your SQL statement. So you can specify that here. You can have data export delivery options, Parquet or gzip file. So these are different options. And finally, where you want to save it. So I can go and say configure a bucket, my cost bucket free tier training. I'll set it to US East and say create bucket. And at the bottom, I have to give a S3 path prefix. So I'm going to say my S3 bucket is the prefix underscore and create. It will create my dashboard, and you can go inside this and you can actually go to that bucket created by this to see the report exports inside this particular my cost bucket, free tiring. And inside here you can see all the once the buckets data is available, you can open this, you can download it and check it out every hourly basis. So that kind of completes our project where we have accessed the AWS Cost Explorer. We have enabled the Cost Explorer, we created a custom report which was our first report, and we saved the report, and then we created a cost dashboard and analyzed your cost using the S3 bucket data that is available. Since we are not doing much, it will not show anything right now, but in future when you're doing real projects, you'll probably see much more on your cost and basis. If you have any questions or had any issues following along, let me know and in the comments, and I'll get back to you.